CIL lab project, and I think mostly people joined from our labs. So I have already visited during the installation and UAT mostly institution. So before the training start, let's quickly introduction of the 5G and later on our core team from Niral team and evolution team, Coral team will take care of this training of core, MEC and evolution board. Later on, I think schedule we have already shared with all the institutions. So we will cover drone, core, evolution board, and RU today. So let's start quickly. Short introduction of 5G introduction before training started. So this fifth generation wireless technology is the latest standard for the mobile network, succeeding of 4G LTE. It promises it's revolutionized the way we connect the communicate by the providing faster speed, more reliable connection, and lower latency. So there are some advantage over the 4G previous generation technology. First is a higher speed. So in a 5G we can deliver more download speed as comparative to the fourth generation. Second, the most important advantage over the fourth generation is lower latency. In 5G, we can achieve the lower latency as comparative to the fourth. Latency basically refer to the delay between the sending and receiving the data. So a 5G reduce the latency to as low as up to 1 to 4 milliseconds, making a real-time communication for gaming, remote surgery, and autonomous vehicle are the future of this telecommunications. And more very important, it provide the massive connectivity, means more number of users can register in a single sites, and also it provide the higher bandwidth, because in the 4G fourth generation there is a limitation of bandwidth. There we can use only 20 megahertz band. In 5G in FR1 we can use up to 100 megahertz band in FR1. So this is the crucial for growing the IoT things, where billions of devices need to communicate with each other, from smart home appliance to industrial sensors. One more important advantage, it provides the reliability with better signal integrity and higher bandwidth availability. 5G can provide more consistent and reliable connections even in crowded urban area or rural environmental. As I told, it's provide the massive connectivity. So in the 5G, basically, there are three main slicing. Basically, slicing allow the virtual networks, creation of the virtual networks, which can be tolerant to be specific needs, just like autonomous vehicles, medical services, industrial applications. This means who is providing the networks can optimize the network based on the different requirements. I already introduced the slices in the institutions when we covered the UAT. Basically, there are three slices.
Sir, sorry
First
for
one,
interrupt. Are you sharing the screen?
no, actually, currently I'm giving the short introduction of the 5G. The training
Okay,
will
okay.
start later on. The core team will start this training.
Okay, thank you, thank you.
So there, as I told, there are three slicing. First is EMBB, means enhanced mobile broadband. So we deployed these slices already in your lab. Second one, ultra reliable low latency, that is will provide in the next release. And the third one is massive machine type communication. So basically, there are two type of 5G can be deployed. First one is SA standalone. Second one is non-SA, non-standalone architecture. So in the lab, we deployed standalone 5G ORAN solution, 5G solution in the all 25 lab. What happened in SA? So in SA, all all the core entity is the purely 5G core use. But suppose that the nowadays operator providing the non-stand alone 5G because they have the legacy network 4G and they have already 5G core. So initially, all the commercial operator provide NSA 5G, means the core will be of 4G, but radio will be of 5G. So in the operator took a very less time to deploy NSA because they have already readiness and the connectivity of legacy network and they install on the 5G radio, means antenna and RU in the on the tower. So but in the SA they have to develop the new 5G standalone core and basically the core very vast entity in the telecommunication system because it consists of lot of functionality and entity like AMF, SMF, PCF, AF, NRF, NEF, UDM, AUSF, NSSF, and more are to be implemented as per the 3GPP. So I already told we deployed the pure SA 5G solution with ORAN technology in all 25th lab. So the training started with the core functionality. Niral team will take care of all these entity and they will introduce all the core functionality and how you can use the different interfaces, how you can capture the pcaps, how you can check the configuration of in different amf. So the core team will train you. The next thing, the protocol stack. So mostly you people know that the protocol, whatever used in the network size, the same protocol using by the user side, except NAS protocol. So in the Genode side, 1 minute. Hello. Sorry. Yeah, we were on the protocol sides. So we will discuss here NAS, RRC, SDAP, PDCP, RLC, MAC, or physical layer protocols. And separately, we will discuss in the core and radio sides, user plane and control plane sides. Right. So I will invite the core team to start the training. And Niral team, are you there? So Shoaib, can you make as a presenter Niral team, Shiva Niral Networks,
Okay,
so
okay,
that
okay.
we start quickly?
Siva, right?
Yeah, Shiva
Yes.
Niral Networks.
Yeah,
Okay.
Shiva Nival.
Second. Yes, given.
Uh, so
Yeah,
over
thank
to
you.
you, Shivaji. Take care of all the training and important things. Thank you.
So thank you, Sonu ji, and thanks to TCL and DOT for giving us this opportunity along with VVDN. So hope you are able to see my screen, right?
Sir, it's
Yes,
visible.
yes, your screen is visible.
Okay, thank you. So myself Siva from Neural Networks. and along with me today we have Manu and Venkatesh. All three of us will go through the presentation on the 5G core. At Neural Networks, I head the technology and customer success, and pretty happy to work with VVDN, TCL, DOT team as part of this 5G lab rollout. Um, Basically, Sonuji gave a overview on the different technology and the concepts involved in the 5G lab and the 5G as such as a technology. So we will start with the lab, 5G lab that has been set up across India and 25 through VVDN. And so basically the rollout of this 5G lab was done in terms of the CUDU, RU, and the 5G core and the MEC server. So this is the perspective from equipment that are available at the 5G lab. We have on a server CUDU and the RU is connected to that. And on another server, we have the core. And on the third server, we have the MEC. And all these servers are connected to a firewall router, which gives an access to the outside world internet. And through this firewall router, we can access a management dashboard, be it on the core, on the CUDU, or on the MVC server. So, little bit zooming in on the core server. So, basically, the architecture is like we have a type 1 hypervisor on which we have two VMs, and on one VM we have the 5G core as well as the controller software, and on other VM we have this IMS. And similarly, on the MEC server, we have multiple VMs, and each of the VM can cater to independent application that are written to sort of leverage on the low latency and high availability MEC platform as part of the 5G core. And say, for example, we have a drone, and the corresponding drone application can be run as part of this MEC server, so that the drone, be it for a video streaming capture or any of the analytical functions, can utilize this platform to deliver the end-to-end solution. And various little bit zooming in on the core. The different network functions, which we will see in detail little more later. Different network functions are implemented as a Docker container, and there is SBI layer interface between all the control functions of the 5G core. And we also have the controller, basically a management portal access into this whole private 5G network. And using this controller, we are achieving two functionalities. One is that we use to configure the system. Pretty much a major portion of the 5G core configuration and also this particular controller acts as an orchestration layer in terms of spawning various VMs as part of the MVC platform. We have also given a set of APIs so that the same controllers in the 5G lab you want to create it for a subset of functionality, it can be done, and it comes with a proper security layer of Java Web Token, and then as long as you acquire these APIs can be called, and using the same set of APIs, we can also create multiple VMs on the MEC server. So this is pretty much the overview of the different equipments that are available, and also how the devices communicate to the RAN, and then how these devices can access application locally available as part of the MVC edge cloud. So typically, this is another illustration of how the call flow happens. Uh, Say a mobile tries to connect to the RAN, and then basically, as part of different phases, it goes through an authentication. When the Once the authentication is successful, the PDU sessions are established. And once the PDU sessions are established, there is an end-to-end connectivity for the devices to access either an application on the MVC Edge Cloud or on any of the internet cloud, any of the services. So any data or packet flow that is coming from the device goes through the RAN, and everything is routed through the firewall. And then, depending upon whether it is a control packet or data packet, it may go to the core, and it can once it is a control packet, it is consumed inside as part of the different network function in the core, and if it is a data packet, it is routed back into the firewall router, and it finds a path either to the MVC server or to the internet cloud. So this is how the packet flow happens in the system, and we'll see more details of these in the further slides. Okay. This is a very important slide which illustrates the complete architecture of the 5G private 5G setup. In this, we have detailed out all aspects of the core, and then basically how the core's interface is with respect to RAN to the outside world, meaning the internet cloud, and also through RAN to the 5G devices. So one very important aspect as part of 5G, specifically the 5G core, it has a clear demarcation of the handling of the control plane and the user plane. So the control plane basically handles all the authentications, and it pretty much drives the policy as well for all the configured subscribers. Like by policy, I mean the QoS, one important parameter, and through QoS, the priorities of services can be scheduled, and various other important aspects such as data rate control. like pretty much the data rate on the session level can be controlled by the configured policy. And also various other smaller details such as IP address assignment. Pretty much all these aspects are controlled through the control plane. Say the one of the main advantage in the 5G of clearly demarcating the control plane and the user plane is with respect to the flexibility it offers to even deploy UPF, the meaning the user plane, away from the control plane. Say, for example, we can have a scenario, and in many labs we have also demonstrated this, is that the control plane functionality of the core can be on a cloud, and the user plane functionality can be adjunct to the Gnode B RAN, so that to leverage the routing in an appropriate way, so that the call flows can be quite local. So you can also imagine a service. Say you are in an apartment complex, and there is a gaming service that is offered, and the gaming server can be quite within the apartment complex. I'm just giving a possible use case, right? So you take your 5G phone, get authenticated on a cloud-based server, which can be an operator like Airtel, BSNL, or Geo. And then when you get to play your video games, all your data communication is happening locally. So this is how the architecture facilitates to achieve low latency and high availability of services, making the architecture pretty much flexible and data access local, so that you can roll out a very good user experience. So this, if you, what I was trying to do is that this architecture I was trying to correlate to a service that user can experience by leveraging the architecture. So this is one of the important aspect of how clearly demarcating the control plane and user plane, we can achieve some end-to-end good use cases. Say, for example, the same thing, I think 3 4 months back, DOT planned one hackathon. So in part of all these hackathon, this core was there, and all different application device connectivity were facilitated through the core and through the MEC platform. That was pretty much everything was local within a setup. But going forward in future, many more such points can be leveraged, and uh, so use cases can be rolled out using this functionality. So let's go a little bit deeper in and look at each and every component within the 5G core. Basically, talking about the interfaces before going into the network functions. So as you can see in the diagram, the 5G UE connects to the RAN, and then at the RAN, pretty much the control path and data path are handled. And the RAN or a Gnode B, it establishes connectivity to the UPF through an N3 interface, where we have tunnels established for every subscribed user, and the data path goes through the tunnel to the UPF. And the UPF through the N6 interface talks to various data networks. Say, for example, one data network can be an internet and internet connectivity, where UPF through the firewall router forwards all the packet to the internet cloud. So another interface on the N6 can be connectivity to the MVC cloud. Another interface on the UPF can be a connectivity to an IMS server, where you will be seeing that shortly in your labs, how a VONR call can be established and processed. So once 5G mobile latches onto or tries to connect to a Gnode B, basically, the control path between the Gnode B and the AMF are defined through an interface N2, where the protocol NGAP handles the communication between these two endpoints. And basically, through this, various control path processing takes place. And in parallel to N2, there is also an interface N1. Through the N1, it is the NAS NGAP protocol which is used as a communication at this two interface point, where all the communication between the devices to the AMF are handled. So basically, in control path processing, we have AMF. Pretty much it handles all the handles the, I would say, at a very top level, the registration request. So once a registration request from a device is received, AMF uses other network functions such as AUSF, UDM, UDR to basically check whether the received SIM details like IMSI, SUKI, and with the supporting parameters such as PLMN, whether there is a match with respect to what is received from the device to what is configured in the UDM and UDR. So basically, we talked in the previous slide. We talked about a controller which helps in configuration of these SIMs. So once the configuration of a SIM is done, say with the IMSI values, then association of network slice, then if it is a VONR, association of MSISDN, then the authentication and operator keys, all details from the controller are configured into these UDR databases, and then whatever is received from the device is matched with what is configured in the database. And if everything is okay, we assume that authentication stage pass, and the AMF starts communicating with SMF, the session management network function, to establish PDU session. So here SMF takes the help of PCF, the policy control network function, to see again what are all the characteristic of QoS, say bit rates or the speed on the ULDL for the session that is configured again as part of the database. PCF again interacts with the database, and then it retrieves all the details. So based on the characteristic configured for a particular subscriber, then SMF then sort of interacts through the N4 interface to the UPF to create those, or rather configure those uh, data data session within the UPF, and also establish an end-to-end tunnel with the Gnode B, and so that all the data from the device to the RAN to the UPF are handled, And depending upon the IP address, the routing is facilitated to either internet or to an MEC platform, edge cloud, or to an IMS at the UPF. So, and similarly, the packets from the N6 interface are handled on the downlink side to the N3 interface, is pushed through these tunnel that are specific to a subscriber, and then this is how an end-to-end data flow happens at the UPF side. Um, so I think this is, I would say, the crux of control and data path processing, what the 5G core facilitates in the private 5G network. And there are various other important network functions. So this table gives a pretty much a summary of what was discussed earlier with respect to the three key important network function: AMF, SMF, and UPF. So the functionalities, then the interfaces, and the key role it performs in the 5G. Um, so before we move forward, let's touch upon a couple of important other network functions. So at the communication between all the control path network functions are handled by another network function called as an SCP, the service communication proxy. Say we know that the communication between all the network functions um, is through HTTP 2 interface, and every network function provides a service. Say, for example, there is a UE network registration requested, and AMF will take the help of AUSF. It will talk to AUSF through SCP, through the HTTP2 protocol, and then it will call an API that is a service offered by AUSF to authenticate the UE. Then the reverse communication from these, say for example, the AUSF to back to AMF again comes through SCP in terms of any of the JSON data. So SCP pretty much anchors all the communication between the different control path network functions, and uh, this is pretty much facilitated by another network function called as NRF. So basically, when you all these network functions, they are instantiated, they get connected to NRF and they register to NRF, and they also periodically send a heartbeat to NRF to make sure that the any of the network functions is alive and communicating with other network functions. So um, say for example, so from an implementation point of view, if you see, these network functions are implemented as Docker containers. Okay, so pretty much even if one Docker container resets, then pretty much it can immediately come back, and then it can get registered to the NRF again, and then it continues with its heartbeat. So this is how we can sort of realize in many of these UAT sessions we have explained that how a stateless functionality can be implemented across the network function. So we have demonstrated that you, for momentarily, you stop the UPF, and then the UPF stops forwarding data back and forth, and then when it comes up and it gets re-registered to NRF, um, all the PDU sessions are recreated by UPF communicating to SMF and then recreating the PDU sessions. And then we can see after some time the data forwarding seamlessly continues across these network functions, though there was a momentary disruption. So this is how the whole um, uh, the control path, data path flow across the 5G core infrastructure happens, interfacing with various other external 5G network entities such as RAN devices, MEC cloud, etc. So I will stop here for now, and I can take some questions before we proceed on to other details.
Hello. Hello. Good morning, sir. Am I audible?
Yes, please.
So, I have some few doubts. The first one is related to the screen which you are now showing.
Ah,
So this admin, most of the time we are unable to provide the means we are unable to log in through this interface.
yeah,
So
yeah.
username admin at the rate 1234. So why such problem is there? Because this is not the means is frequently occurring. What may be
So
the reason for this?
we have resolved that issue. Basically,
Even
uh,
day before yesterday also, we have raised this we have shown the screen print to the VVDN that we are unable to log into this.
so which is this site, sir?
This is University of Hyderabad.
University of Hyderabad. Sorry about that, but we have resolved this issue, and in most of the labs we have applied the fix. And it was a way of handling the reset of different containers, specifically the controller, in terms of properly getting back the data to the controller. So there were some issues that we have resolved, and to best of our knowledge, we have applied those fixes at multiple points. And there were also some temporary VMs we were using in terms of to showcase some features like
Exactly, that even the temporary VMs also sometimes is they're not functional, in fact. So that is
Yeah,
also
correct.
an
So
issue.
what we are doing now is with VVDN, we are testing the final software, and it is quite satisfactory over the last 2 weeks. So we'll coordinate with VVDN and the individual labs, and then we hopefully in the next 1 week or so, uh, you will not have this two cores running everywhere, and it will be just one core because we have stabilized everything, and then all these type of issues you shouldn't face going forward. And also there are other three four features which we want to showcase, which we are also making it ready through those the final software.
Yeah, okay, of course, this the same thing is repeating from quite some time from the UAT onwards.
Yeah,
Most of the time
yeah,
we are hearing this. Yeah, yeah.
yeah. Nagendra sir, basically, the core team developed the new one image. This is the upper version, and we have tested successfully. Last 10 days, it was working all the setup properly, right, in the DTU.
DTU
So
means
we will
Delhi
apply,
Technological University, right? Right.
yeah, DTU, Delhi Technical
Okay.
University.
Okay.
So we will show you via the remote, right? We are here in the DTU. So after the successful testing of this core, we will apply all the 25th lab. We will deploy the same
Okay. Okay.
for the
Kindly do
next.
it. Yeah, kindly do it as quickly as possible because we are held up with so many other tasks to be done following up this particular testing.
I can
Kindly,
understand, Nagendra
yeah,
sir. Yes,
yeah,
sir.
yeah, please.
So almost we have tested successfully and the stability test as well, right? So most probably in next 2 weeks we will apply on all the labs. Most probably.
Okay, if I can
Thank
just continue, there is a couple of queries. Uh, so, uh,
Sure. Okay.
yeah, yeah, just this question is for the Siva and neural networks. So, hello, can I
Yes, sir.
proceed?
Yes, sir. Yes.
Yeah. So, on an MEC server, we are trying to deploy our own virtual machines. Uh, so, we are trying to add our own use cases by adding those virtual machines. Most of the time, the storage capacity, of course, it is showing very less actually, 20 GB. By default, it is coming. And if we have to add more use cases to that through the MEC server, then how do we move about? Hello.
So I think that one you can increase yourself capacity because we provided approx in TB the storage.
Right. Yeah, that TB is not matching to whatever the TB which you are saying. It is not matching to whatever the physically it is existing there. So somehow that kind of screen print also we have shown to the VVDN to correct it, but still it's not yet corrected from the UAT since the UAT has been completed.
Everywhere is so now. Okay. Uh, let you know. We will take your remote.
Yeah, okay.
Surely we will.
Hello.
Okay, I will proceed now on the
No,
controllable.
Shivaji. I think Ayushman sir also asking some doubt.
So can you re-explain the packet flow, like when you were telling in the like how it is going to RU or and what were the different kinds of packet? And my second question is, has the SDN dashboard IP changed, because earlier it was I think 192.168.0.4. So here on the screen it is reflecting 88.13.
No, 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 sir. Basically, IP will be the same as we configured.
So point 0.4.
Yeah,
And
this
please
is the
explain me the packet flow for different like kinds of packet that you were showing. I think it was second or third slide. So how it is going for like from RU to ORAN to server.
okay. Sorry, your voice is nothing. I think are you asking about the are you 192.168 4.50 RUIP? I didn't.
No, no, no. Sorry,
Sorry,
sorry.
I think more voice from your sides.
Is it audible now?
Sir, Sonu sir, basically, if you go to the second slide of the presentation, sir is asking about the flow of the packets.
Exactly.
Okay.
Flow of the packets. Actually, if you go to the second slide of the presentation, what Siva sir has shown to us. Uh, yeah, this particular slide, the flow of the packets from the 5G phone. So
Yes,
most likely,
exactly.
Ayushman sir is asking about this flow of these packets. So instead of orally telling, it will be better to show the step-by-step flow of the packets from each entity. That will be better.
Okay. Mm. Yeah, we we can show through Wireshark those details, but before that, please give us another 15-20 minutes. We will cover other aspect so that everyone can have a basic understanding. So this is the controller software. Pretty much, it at a very high level, it provides configuration capability, statistics, and alarm manager capability. So we have, other than to give an overview of the system, we have an overview page. It covers all the devices, the number of radios, the number of sessions, It gives traffic on the N3, N4, N6 interfaces. It gives listing on the top five devices. Then there is also a topology view where it gives a list of the VMs, uh, the core and the different containers within the core, and on the control path and data path it segregates. It provides a view of the Gnode Bs connected to the AMF, the N2, and also if you click on the Gnode B, you will have the list of UEs that are connected. It gives a basic uplink downlink data. It provides whether the UE is active or inactive or idle. So all in the latest DTU release, a lot of new functionality and stability is there in the overall system. Then, from a configuration aspect, the way it will be is you can configure a list of APN, that is the DNN. So you can have one for internet, one for IMS, etc. Then you can also have one for the MEC. Um, then once the APN is configured, then you can configure the network slices. In the network slice, you can pretty much on the per PDU session level, data rate, QoS, IP address, all these details can be configured. Then once these base configurations are done, you can create a subscriber with the different authentication and subscriber keys. Then to that you can associate a APN. Rather, you can associate a network slice, and the network slice internally will be associated to a APN. Then these are the statistics board where it provides the insight into throughput. Now in the latest release, uplink and downlink are separately segregated with different colors. And then we have both the device and the radio control. So within device, we have on the control side, it pretty much provides how many registrations are attempted, how many successful. And on the user side, we have the statistics on the UPF. Then inside the UPF, you have statistics on N3, N4, N6 interfaces, so that the UPF is clearly dissected and all the interfaces are outlined. And then the next major category is the alarm manager. And in the alarm manager, different alarms from various network functions are handled with respect to both the network functions going down, coming up, and all these details are clearly captured. Um, before we'll quickly have an overview on the Nirlos Edge, the MEC platform. So basically, as I said, this MEC platform provides a platform where you can use the low latency and high availability, and then make application available for the devices locally to leverage on these two functionality. So the controller also provides an orchestration functionality so that you can create, delete, view the statistics of the VM, upload the operating system of your choice, and define the VM the way you want in terms of storage, in terms of memory, in terms of operating system, etc. And with this and the co-location, we can pretty much leverage various applications. And this is the architecture which outlines the MEC connectivity through the N6 interface. And also there is an MEC interface available through the APIs from the controller. And so we can create the VMs, and we can pretty much maintain them, and then make it available for the local devices to access. So once a VM is created, we provide a desktop view, and any of the applications can be installed, and also any of the interfaces that we want can be created in this VM for the devices to access. So um, so this is a overview. Then we are planning for a couple of more details. One is with respect to uh, just giving an overview of how the controller functions. We will initially do it through a simulator and show how the statistics varies. And so over to you, Manu, to demonstrate these details. And then after that, we are planning another session where through the Wireshark, we can demonstrate the NGAP, NAS, PDU session creation, and all those details, or of the GTP packets, all the details how across the VMs and across the server the communication take place. So I'll stop my presentation here, stop sharing it. So over to you, Manu. So Sonuji and Sushilji, you can give access to Manu.
Manu.
Yeah. Well,
Yeah, Manu Shi, right? Shivaji?
Ah, yes, yes, yes.
yeah.
Okay. Shoaib, please make a presenter Manu Shi.
Okay, okay. Manu Singh.
Yeah, Manu Shi.
Okay.
MANU space Shi.
Yes, given. Please check.
You want to share it?
Hello. You're able to see my screen, right? Hello.
Manu, your voice is muting.
Hello. Hello, sir.
Yeah, you can proceed, Manu.
Okay. So, so this is our dashboard login page. So once you this IP 170.16.0.5. So you will get this login page.
So this is the management portal access.
Any disk is
Manu, I think this one for DTU, right?
Yes, yes, DT1.
So, hi team, don't be confused that IP 172.16.0.5. I think you have already 22 or 20, right?
22 for that MEC one.
MEC, that one. Okay.
This is for the core controller. So this is the overview page of our 5G controller. So you can see this overview, the active core, active radio, and registered device. So this is the in. I'm showing it one example through the simulator, virtual simulator. So
Manu, 1 second. So
okay,
you can have a view of the latest software that's going to be installed. The key difference you can see is on the top. The Initially it was only a registered device. Now we are segregating and showing whether the registered device is an idle or active. That is one, and you will see that down below the traffic details, say on the throughput user plane. You can see the differentiation of both uplink and downlink.
yeah. So this is our simulator. One here I'm running the one Gnode BA. So this is the command for running the simulator Gnode B. So you can see in our dashboard that radio will be active. Radio will be two now as of now. So one is for the virtual simulator radio, and one more is the real radio, which is connected to it. So that details, if you want to see it, if you click on this radio step, you can see these two radios are connected. So the one is running from 3 days, and presently I running on the virtual simulator. That is time you can see the 20 to 28 second like that. So like
So
this, I will
sorry to
connect.
interrupt.
Yeah.
You have shown like virtual GLB, na?
Yes. Yes.
So
One
how yeah.
that is a one more simulator VM will be there in your setup, actually lab setup.
Okay.
Using that we are demonstrating. So that ID is of one, actually. You can see in the radio, active radio is there, right? If you click on that tab, you can see these two are radio and ID one. One is for simulator.
Mhm.
208 is the real radio.
Physical one.
Yeah.
Okay.
Hello.
Yes.
This simulator that which you have created, that radio is from this Nirala network. We can create this one, or we have. I think I just missed that part.
Actually, this simulator part is the in 5G lab it's set up itself. We have one VM called Neural Sim. In that you can see, like you can access this particular VM. So this is for only for virtual simulator, like for testing the software. Like it's not, it's like a actual radio, but it will be there in simulator. Like it will be virtually, it will act like a real radio.
How to create that type? I'm asking. Like,
It's
did I miss
already
it
there
in
in your
previous? Okay.
it's already there in your setup, actually.
Okay.
So there is a VM called Neural Sim that using that
Mirrors.
VM you can, yeah. This is the command to run, actually. This one sh file is will be there. Start gnode bsh. If you run this, it will automatically Gnode will connect. So now I'll run one of the UV connection. So one UV I will connect here. So this is the command to run the UV one. So now this particular UV is connected with the IP. You can see here 10.10.6.68. So this UV is connected. So that particular UV can able to see it here. Like if you click on the register device, so this is the one UV is connected actually. You can see the IP also, particular IP it is obtained. You can see this is the IP it is obtained from, like previously shown in the simulator we have, right? So this is the IP which currently that particular EV is connected. That IP is 68, 6.68. So once it is registered, that will come to the registered device. So when any active device, like for example, one device is active and running, that time this active device will come, and any session, for example, if one UV is browsing internet or you watching YouTube or any Instagram, this thing, that time this session will be equal to one. Like for example, here now three UV is active, so that have the sessions of five actually. So one UV will be connected to two sessions. That may be one is from IMS and one is for the internet. So if it is, for example, any one UV is connected, but that time that is not browsing anything. Like for example, it is idle. It is in idle state. It's not doing. It's not doing anything, or like it will be use, like it is not browsing anything or doing nothing. That time that will go to the idle mode, idle device mode. So that device is actually, for example, currently one device is in idle mode, idle state. So it is the idle state one. So if any session is going on, that time this session will, active session will be increased. So when for example, these many devices are registered and it is actively it is there. So in that three devices are active, and the three devices have this much sessions, five sessions, like that it is showing. You can see this actually one more device went to the idle state. Now again it came back. So like this, it will be the overview page. And if you come to the downside, there is a throughput tab will be there. This is the overall throughput. For example, if you are doing anything, like for example streaming video or watching videos, that time this throughput will be increasing. Like for example, this is the uplink from UV to that internet browsing internet will be uplink. If the any downlink is coming, that will be represented in the blue color. So uplink will be represented in the green color. So sorry, yeah. And this is the user plane. For example, in there is a in 5G architecture, you saw that UPF is a user plane function. It is connected to three interfaces, N3 and N4 and 6. So according to the interface, you can see the how many packets are flowed in that particular interface. This, for example, it is showing the N3 interface. These many packets are flowing in that particular interfaces. So that's details is showing. If you want to see the N4 interface level, that time you can select the N4 interface level. So this many packets are flowing in the N4 interface. So like this, you can select for N6 also. So this will show the one level of graphical representation of the how many packets are flowing through the particular interface. And
Sir,
if you
is this
come, yeah,
sir, is this throughput will be affected by simulator UIs also?
yes, it will be happening.
Okay.
But I'm not doing anything there. If I
How to
ping any
browse? Sir?
through the simulator, you're asking.
Yes, yes, yes. How to browse
Uh,
and how to do the things in simulator
yeah,
UIs.
you can see one tunnel interface created. You can see UV sim tunnel, tunnel 0. If you're connecting multiple device, it will be increase 0, 1, 2, like that. It will increase.
Huh.
In that tunnel interface, the tunnel interface will be there in this VM itself. You can see this is the tunnel interface having the IP of 6.68. So I will use that particular tunnel for that the ping. This is the tunnel one which is created. From there tunnel to I'm if I'm browsing any Google or anything, that time I will, for example, I will browse Google now as of now. So if I'm pinging this one, so this thing will be reflected here. It will come here actually in top active device also. It will be there in the throughput also. So this ping will be having some less by, like for example, it will not be there in KBs also. It will be just I'm browsing the Google, right? So it will not consume that much data.
Okay.
So if you are if you are using any hyper tool like that, that time it will be affected here. Like you can see the fluctuation in the throughput graph. So this is overall throughput, like for this many duration having this much throughput like that is useful. You can see the 1040 to 1050, but every 10 minutes you can see the throughput like that.
Okay.
Hello.
Yeah. Yes,
And
yes.
we can store this data somewhere in a log file.
Which data?
This throughput and all, like for a particular session, if I like to see the throughput uh, by a particular link, right? I
Um,
like to keep the data stored somewhere.
The CSV format and the statistics.
I think as of now, this.
Manu, we'll take that question.
Manu, can you go to the statistics? So here the download button is there, right? Just per user we can download it here. Like what is that? How many sessions each US is consumed, and what is the bandwidth it consumed? We can download the overall stats here per UE. Can I download it?
Okay, thank you.
Yeah.
So next tab is the top active devices. Here you can see the, for example, if any multiple devices are connected, that time top active five devices it will show the data consumption. Those things it will show it here. For example, this as of now, the only one device is consuming this much data. You can see the uplink also and downlink. If you click on that, you can see the in that overall how many uh, data consumption is happening for the particular EV. So you can see the IMSI number also, the particular IMSI number consuming this much MB. So you can select it for month also. You can select it for week, like duration also. You can select it like that. There is a one tab called. You can see the like one filter is there, right? This hour, according to the hour, you can filter it. According to the week, you can filter it like that. It will be the top active device will be working. So this alarm next, this alarm manager tab is the main alarms only in this overview page. The main alarms, for example, any um, okay, alarms are regarding the 5G core. For example, if any radio goes down, that time, if any network function goes down, that time, these alarms will be generated. So there is a one more. This is one like I like in overview page. There is a main alarm displayed. If you want to see the in detail alarm details, you can see there is an alarm manager tab is there. You can see the top down, so you can see the view also the particular alarm what it is giving and from where the error is coming. So if you click on the view button, so you can see the details here. So this alarm ID will be of 3GPP standard, and from where alarm is coming, source type, and which network function is giving the alarm, and the the description and the destination from where it is coming, and if you see the reason also, you can see the G0B goes down from the AMF. Like you can see also, if you want to the solution, that time you can see the solution also here. So and this is the level of the alarm, and if this particular alarm is resolved, that time you can change the status to resolved. You can see the button is there, right? If you want to resolve this alarm, if particular alarm is resolved, that time you can resolve it by clicking on this status here. So this is all about the overview page here. So we'll move for the topology one. So here you can see the topology page here, right? So we'll zoom out. So this is the one, like for example, our 5G core is like how architecture is built upon, and how the core is connected with the user plane and control plane function. Like, you can see this 5G core user plane, so that is connected with only UPF, and 5G core control plane that's connected with these many network functions. Overall these many network functions are, is there in our 5G core architecture. So only the AMF is the main contact for the G node B or any AD is connected. That time the AMF is the anchor point. So in this anchor point, you can see the G node B1 and G node B2 node 8. So G node B2 node 1 8 is the real radio, and this one the virtual radio. If you click on the particular radio button, you can see the in that particular G node B how many EVs are connected. You can see the SIM number down here. So this particular SIM is connected with the particular G node B ID1. So in that you can also see the view the IP of the particular session. You can see this is the one IP of the particular EVs, and also how many packets are flowing in that. So these things you can see it here. And if you go see, you can also download the that particular sessions data. You can see the one download button is there here, so you can download the particular data of that UV also. So in this, if any, like for example, these many network function are active and running, running status is whenever it is running. That time this circle will be, and this green color it will be shown. So whenever the particular any network function goes down or any G node B goes down, for example, in the real time, I'll show it with simulator. So as of now, this G node B1 is running, and you can see the green color, right? So if the particular G node B goes down, that time the this button will be changed to red color. Yeah, you can see, right? The simulator G node B is not connected with the 5G core, so that's why it's going in the red color. So like this, all these network, like if you any network function goes down, that time you can easily find out through the topology.
So the IPs you have shown
Right.
now, sir, just now, those will be changing now, sir, each time whenever we.
Yeah, yes. Like each time, like for example, if you connect, if you now it is running with some 6.68, right? In the and this is the simulator VM. So this presently this one is connected previously. If I connect reconnect that time the IP will be changing. IP will change to 69.
Right.
Each time the IP will be different.
Hi, Manu.
Yes,
Hello. Uh,
yes,
so you told about like we can download the data. So it was near the map, no, the download arrow. The symbol was
yes,
there.
yes.
So will it be downloading just the like the graph that it is showing, or will it be downloading the whole data? And if it is downloading the whole data, like what will be the format, CSV format or something? Like
I
what
can
is the
show you. You can see the date, day and week like that. You can download it. For example, I download for day. Actually, you can see this is the
CSV
project.
file? It is.
Yeah.
Okay, and like I missed like a few minutes, so I don't know. Like whenever we are connecting, let's say our camera or IoT or mobile, the number of sessions are only one. But why it is that when we are connecting the drone, it shows like two active sessions? So is there any reason? What is the reason behind it?
That is displaying the overall session. For example, I will show you. In this, you can see the four session, but when you click on this I button, so the overall, like previously in this particular device MC number, how many session are connected, and those things you can see it.
No, no, I
And
understand,
state
but
present
when
one,
you
you
go to
can see the
device and user plane, like when you are connecting the mobile, it
yes.
shows one active session. When you are connecting the, let's say, IoT device or the camera, it shows only one active session. But like when we connect the drone, it shows two active sessions. Uh, so when I checked, the IP was same for both. Maybe because only one SIM we are using. But like, why it is the difference? Like mobile, it shows one active session, and the drone it shows two active sessions.
In like
Let me answer for
when
this
you,
question.
okay,
Yeah. Actually, usually for the voice-centric mobiles, it will create two sessions. One for the default, that is for the internet, 5Q9, and another it will create for the like 5K, one for that IMS. So if you configure that VNR on the time, it will create the two sessions, two default sessions.
Okay.
If it is a voice centric, if it is only data centric, on the time it will create only one session. That is a 5K9 only it will create.
So is he talking about PDU sessions?
Yes, you are also talking about the video sessions only, right? So in this here you can see right session counts are there. That is actually PDU session counts. It's the overall session count of that UE, but it's not currently active. If you want to see the active current session of that particular UE, you want to go inside that tab. Can you open one of this?
So sir, it is possible that a GNodeB is connected to Wi-Fi and it's connected to mobile. So this our GNodeB is actually telling all total number of session, PDU session coming from different parts.
No, no, no. So, as Venkatesh explained, we can have two sessions only in the scenario of voice-enabled VONR devices. In no other place we can have two sessions active. So far in all the UAT labs, since we have not seen this BTU, what you see is a next version, which is not available in other labs, but which will be shortly upgraded. We were testing it in DTU. So in DTU, yes, the VONR is also enabled, but sort of we'll go through more testing before we demonstrate it to you and install it at your place.
So I believe in our setup in our colleges, the VONR is still not enabled because it was like I think it was planned for next release when the UAT was happening year ago.
Yes, sir. VONR actually in the UAT document also we have put that particular clause on this as
Exactly.
still in the progress. So we are asked to put that as in a progress. We have not tested it.
Still, like my question is the same. Like I could not understand when we are connecting the drone. What we do, we go to the user plane and we get the IP address from it, and then on the Supernas, Superna the application that you have given, we are going to fill the details and then we connect. So when we go to the user plane, no, what you are showing ours is a bit different, as you are telling that you have upgraded in the DTU and not in the other colleges. So why it shows two active sessions? Like I have seen it actually. It shows two active sessions for a drone, and for all other equipments, it is just showing one active session. So like, I could not understand the reason for why it happens. I currently don't have a screenshot or something. Otherwise, I would have it shared.
So probably you that two sessions what you are seeing in the drone, right, would be temporary. A trigger from the drone software might sort of try to create that, but in all your labs, since VNR is not enabled, meaning IMS is not there, that maybe after some time you see that won't be available. The release, it will be released. Maybe
So,
later on, when everything is implemented, then we'll have to check that scenario and confirm that it is successful.
it is not temporary because, as I remember, it remains two sessions for whole the time that we are using the drone, and after that, it okay, maybe.
Actually, in the previous version, there is on we were only handling the activate and deactivate of the each session, but currently we are enabling the ideal also. So maybe that state is not showing properly in that particular like UVs. Maybe that session was in ideal state, but it is even showing the active. While we update the latest version, this kind of the issues will be fixed.
Okay. So, like currently, I'm not able to connect because it is showing network error. Maybe because two versions of the core are running as usual. So, sir, one more question. So, every packet is coming from SD-RAN, the firewall. So, there we are also collecting the similar statistics regarding NAS and regarding, you know, NGAP GTPU. There we are collecting it or not possible.
Yeah, this is everything a core perspective, both the data plane and control plane side. This we are here we are not collecting anything from the RAM.
No, sir, but the
Like
packet is like if we talk about N1, N2, and gap is coming. So the NAS is coming through firewall to core, right? And if GTPU's N3 is coming, that's also coming through firewall, then to core to UPF, then to network through firewall again. Is it? Am I correct in my view? Because
Yeah, yeah,
everything is
correct.
going.
All packets go through the firewall between every server. That is how we have configured it.
Even PFCP also on N4 also going through the firewall to UPF, sir,
no,
or it
actually,
is.
yeah, I will answer whichever is exposed to the outside of the core that will be come over the firewall. That means N1, like N2 and N3, like N4 is between the core, between the data plane and control plane. So that will not go over the that is over the local network within the within the Docker network. So here you can see only the N2 and N3 want to be exposed outside. That only want to talk to the G node B. That only will go over the firewall. That packets only will come over the firewall. Other things will be internally communicate.
Okay, sir. Thank you.
Yeah.
Money, you continue.
Sure. I think topology is clear for you, I think. So we'll go for the statistics. So in this, you can see the user plane one. So in device
Excuse
stat,
me, sir.
yeah,
Uh, yeah, your that critical condition. Can you just go back to the previous screen? The alarms one. Here now again at 11:49. Again GNB goes down from AM. Why
yeah.
it is coming? You may know that because at 11:28 again it was
No,
previously it
this is
was
from
down.
the simulator. This simulator, I switched off it
I
till
thought you
11:40.
just stopped it. Okay, okay, you have stopped it manually. Okay, I got it.
So statistics for this is from user plane. So in the user plane, you can see the like the devices which is connected, and the user. You can also see the here this particular G node B which is connected with this G node B ID. Like one is for the simulator, so it is connected for this one, and this particular UV sim is connected to 208. This one real radio, and you can see the status of the uplink bytes and downlink bytes. This will be in the aggregate form. So and also you can see the particular, for example, this is one UV is connected previously with the simulator. So if you want to see the more from this particular, you see, so you can see the all the sessions which is connected previously, and also in that particular session how many uplinks went, how many downlinks went. So in this previous session I was pinging to Google. So this is the data which is consumed. You can see the downlink and uplink. So previously I pinging to Google, right, using the tunnel. So this is the consumption of that particular session. And also the in that session, what is the IP which is connected with UV? That IP you can also see, and also you can also download that also. So and also here in that session, uh, previously in this particular session, so what are all I did, those things also you can see if you click on this I button. So you can see that I'm periodically I'm pinging to the Google. So that the things is showing. You can see, right, internet. I'm using the internet. Using the internet, I was able to ping the Google. So that IP and packets also you can see it. Everything you can see it here. And this is the slice. It is in that slice only I'm able to accessing that internet. This DNN I'm able to accessing. So this is the one session management tool, so SMF. So this will be handling the sessions. So in that particular session, I'm using this like that. It is showing the in
So
detail.
the time value is different.
Yeah, this is every session like periodically it will be changing the timings. Every 1 minute you can see the 32, 33 timings will be.
No, 633. What is that 633 and is indicating?
It's a GMT timings. I think it's will be time zone will be different. I think, that particular.
So is it like the heartbeat is coming, saying like SMS alive or something like that?
Um,
Actually, this is based on that container time. That maybe that SMF have some mismatching time with this system time that we would have to see. But these data are we are getting from that URL report. Usually, UPF will every 30 seconds or it will reach some threshold limit on the time per session. It will send that what is the consumption of bandwidth, both uplink and downlink. It will send to the SMF. So from SMF, we are collecting these logs and showing us the statistics here. You can show the flight tuple if it is enabled here.
yeah.
Like open any active one. Previously opened one, right? Yeah.
One, and I think
Flight tuple. Okay, here you can see under the session 10.101.6.79. In this session, what are the service different flows are happen? Like each sessions have a different SDF flows will happen. This we cutting from the data plane side. So here you can see what kind of protocol and that you want to reach which IP. Maybe it want to 74, 125, 200, 102. That is maybe one application. And here you can see the destination IP. That is the UEIP. Like here we can see the what is the actual data path it has to be reached. Like in future we plan to implement that DPA also. So on the time we can able to track the what kind of application it is using, like a Facebook or a Instagram, like what kind of application the user use also here we can track.
So basically, you can also say as part of different experiments, right? You can run DPI in one of the VMs in the edge cloud, and then you can pretty much track all the applications that are being accessed from different devices. So uh, maybe we'll see if in the next release we can install one sample for and then you can try to use that. But independently, these are the effort colleges we would suggest can initiate, like use open source DPI, and then see apart from these values, if you can also create one DPI to analyze the traffic on the devices.
Sir, a question, a simple question, may be useful. So, Neeral's SIM is provided by you, and I've seen the UERAN SIM. So, is it possible, sir, any hook available so that we can try up with SRS RAN or 0MQ or any other simulator to be hooked? Is this possible from the
To
user
to
side
our
or no?
Actually, yes, I will answer. You can't able to for if you want to connect the SRS NAN means you have that like a radio unit want to be there, right? Otherwise, you can enable that ZM key option. On the time you can attach with the simulator and you can try.
Yes, sir, that thing. Okay. Thank
Yeah.
you.
Yeah, Monu, go ahead.
Okay. Yeah. Next is the control plane. You can see the in this like how many registration attempt came from the so UVs. There's things you can see it here, and also PDO session establishments. How many PDO session request came and how many success. Those things you can see it here also, and also see you can see the failure here. Like in this failure, you can see the cause also that this DNN is not supported with the no slash like DNN this particular in that count that failure is of the DNN is not supported. Like this, you, failure details also you can able to see in the session establishment, and also this is the aggregate session release means whenever any that is session is not usable, that time the session will be released. That aggregate data release will be shown it here. And if you come to the radio part, so this is the radio, the like how many radios connected and the history of the radio, and you can see the registration attempts, how many attempts came, how many it is success, and how many it is registered, and if any failures happens, that time it will show it here in the registration failure. So currently this is the zero one is the simulator VM. So I previously disconnected this the radio, so that's why it's not it's showing the deregister status. So it is also showing the timings and duration of active, and also you can see the history also here. And this is the one real radio it is registered actively, it is connected, that's why it's showing the status as registered. And from last 3 days it is running, so that timing also you can see it here of for last 3 days. And this is the PFCP related one, so you can see the there is one interface is there, right? So that in that whatever the registration attempts for the session related, those things you can see it here, like from SMF to UPF registration attempt. And you can see also the UV sessions establishment, UV session request, and how many it is success and how many is a failure. So this is the establishment, and also you can see you can there is a drop on is there. You can also select the according to the modification information. So if any session modification is at that time, you can choose how many session are for requested for the modification, and how many it is modification success happened. Those things you can see it here, and also failure, and there is a deletion information also will be there. So if any session is deleted in from the code, that time you can see the like count also of how many request came, how many deletion sections success happens. Those things you can see in this tab. And if you go for the UPF, previously in overview page there is a one user plane section is there, right? These crops. So there is a one more tab dedicated for the all the data which is coming. You can in detail you can see it here. So this is of the N3 interface. In this N3 interface, what are all the data is flowing, like how many packets are flowing, and this is the aggregate data, aggregate public data packets and downlink packets aggregate, and this you can see in the graph itself. So the how many are flowing currently. You can see it's in packets. This is in bytes actually. So this many packets are flowing to in this particular N3 interface. That is actually currently this much packets are flowing. So that's what it is showing here. And this is the overall one. You can see the total aggregate uplink packets and downlink packets, and this is in bytes actually, aggregate uplink bytes. So this is in packets and this is in bytes actually. So, and also you can see the drops also, how many drops is in that particular connection. These many drops are happening. That's the aggregate data. These are all be in the aggregate data. So this is for the N3 and this is for the N4, and this one is for the N6 interface. So in the UPF section, the connection you can see in the diagram, right? So this UPF is the managing the packets flowing through the N4, N3, N6. So all these interfaces will be managing by the UPF. So this UPF is mainly handling the packets, whichever all the packets are flowing through the UPF. So it will be handling the packets. It will be measuring the packets and how many packets are flowing. All these things will be uh, captured by the UPF. So this is all about the UPF statistics. And if you go for the configuration, so you can see the while adding subscriber, you can see you have to give the APN details. For example, for one session, the internet is there. Uh, Yeah, you can see the APN. APN means a DNN. You can select the APN DNN say internet. Internet means, for example, if you want to browse any internet or Google, that time by default internet will be used. So if in coming days IMS will be like, for example, VONR configuration is there. For that we are using the IMS APN value as the IMS. So according to the every like if you create any APN, that will be assigned with the one APN ID, one and two. Like for example, if you create one more APN, you have to give the name, and if you click on APN, that will be generated here. That have one APN ID of like for example, these two are one and two. If you one more you create new one, that time it will be obtained with a three. And also you can edit the particular APN also by clicking the edit button. You can also edit this particular APN. And next to this slice one, so slice you have to, like for example, if you're adding in this currently you are using the this is the one slice. So in this slice you can see here, right? I think, yeah, in this you can see the slice you want to like 1 2 3 is there. As of now, slice service type, as of now you are supporting the EMBB version 1. One is the EMBB, and slice differentiator you can give it as a in this site actually it is configured with the 010203. So in that particular slice there will be sessions will be configured. For example, by default we are giving in the internet session. You can see once you click on this session, there will be drop down is there. You can see the ID. According to the ID, APN ID, you can able to select the DNN. previously I created the APN, right? That APN will be assigned with the IDs. According to the IDs, you can select the DNN here, and you can also select the QoS value. If I QI9, this will be of video streaming, video buffer, those things for the 9, and also 5 will be for the IMS one that will be enabled. And so this maximum data rate is there, right? For example, in this slice, this particular slice should be having the uh, throughput speed of 1 GB. So if you want to restrict with the 100 GB and the 100 MB also, you can also create it here. Like for example, if you want to create it for 100 MB, that time you can change this unit as a MB, and you can configure according to the restriction you want to give it here. In this particular section, you can also restrict the um, like maximum bitrate and throughput of the particular session. This is for downlink and uplink also. And after this slice creation, if you go for sim here, you can
Uh, 1 second, Manu.
yes.
Back in slice, right? You can also showcase how we can create additional PCC rule where um,
Oh, you can see the one more session there after in the session under only there is one PCC rules is there. If you click on this PCC rules, according to the for example, so one is for the QS. QS one is for the um, like voice call, and like there will be one and two will be the 5Q value. So those will be for VONR configuration. So according to the PCC rules, it will be selected. Like this is priority, or like this particular QS will be giving priority of this two. For example, if you're giving as a one, that time it will come up with a priority of one. So like this, you can create multiple PCC rules under the session also. So this is one PCC rules. You can also add multiple PCC rules here. So you can change the QoS to two is for the video call, one is for the voice call. Under the five, it will come. These two will become, and also you can prioritize the particular 5Q value. You can prioritize the allocation here.
and one more point is that while creating additional PCC rule, we can also implement the guaranteed bit rate. So this will be useful in the VNR scenario for a voice call. What is the guaranteed bit rate we are offering? So basically, there is a concept of default channel and dedicated channel, right? So the default channels are like nines, five, and dedicated are like with a higher priority one to offering a guaranteed bit rate. So these QoS related information can be so driven through the slice configuration.
So, sir, normally in public 5G network, this information should be coming from charging functions to PCF, right? Or it's going to SMF, sir. I'm not able to understand that. I mean, where you actually sending these rules imposition on an SMF or on PCF, sir? I think it's
Actually,
PCF.
in this current architecture, we don't have that charging function. So everything we will be configured via that our dashboard. It will be this data should be taken over by the PCF. Like whenever it want to provision a new policies to this particular session or this UE, on the time it will PCF will inform to that SMF and AMF based on these data.
Yes, sir. Thank you.
So next section is for the sim one. So you can see after adding the slice and the APN, so you can create configuration according to the year. You can see the if you want to create one sim, there is one section called sim. If you are creating multiple sim, that time there is a button called bulk sim. So if you want to create first SIM, you can see this is the MNC MCC value, mobile country code and the mobile network code. So this is of the PLMN, private PLMN. It will be provided to the institution. So for example, in this PLM will be the 001.
Manu, sorry to interrupt you.
Yes.
I think some of the institution during the UAT wants to know the detail of what we configure in the same regarding OPC, KI, MCC, and MNC. Right. So you can take care of these things here also.
Okay.
What are the configuration in the SIM we configured at SIM
Okay. Yes.
KI OPC value. Show them also.
Yeah, sure. So in this session, you can see there is one key management is there, right? So if you click on this key management, so this is the one key is configured with the SIM which is provided to you in the like all the 5G labs. So this will be having the keys of this one. So if you want to create one more key of that configured, so you can add this using the key button, add key button. So you can select the key name and the type of the OP or OPC value of the SIM type. And this is the OPC value. And this is the where you can give the key value of that subscriber key value here. After giving, you have to click on this key. So it will be created in this section, key management. So if you want to view that particular key which is created, so if you click on this more information, there is a view button is there. So thereafter you can say verify the which is created key will be correct or not. You can verify it here. So this so yeah, you can create the OPC and the subscriber key. So once after creating this key, so if you go to for adding SIM, you can see give the like MC number according to the PLM, and this is the PLM which is provided. So you can see the first MCC code will be the 001 and mobile network code will be the 01, and this is the 10 digit phone number which is configured in the SIM. That same details you are giving it here. So that you have to give you the 10 digit number here. So that will be combined with the this PLM 00101. And also the previously I created and this is for example I'm showing it. So previously we created one key and OPC value, right? So that will be selected using this tab key tab. So there is a one key called sim key is there. That name you have provided, that name will be displayed in this drop down. So if you create one more key, it will be what after creating that will be available here in the key section. So this is the one key which is available. So you can select the key according to the sim configured. So then after you can go for this is the slice you have to select. So you can see this once after clicking the slice. So in the drop down you can able to see the which are all slices available. Previously I created one slice that will be showing it here. If you are adding one more slice, that time it will be available in this drop down. So according to the available slice, you can select the slice details. If you want to update any particular slice detail, also you can update here. So you can see the here in this session, you can also give this particular this MC number is there, right? So in this MC number, if you want to give the static IPs, for example, now you're whenever the any mobile or any 5G device connected, that will obtain some random IP. So if you want to give the static IP. On that time, you can provide here whatever the IP you want to give it. Like for example, if you are connecting uh, drone, every time that drone IP can be whatever you static IP you are giving, that IP you can give it here. So that will be of in this subnet 10.101.0.1. In this series, it will be there. So this is actually a static IP for that. For example, without giving this if you are not giving the static IP, On that time, this will be obtain one random IP. So that IP will be you can use it for the. And once after this slice selection, so in coming days the VNR will coming. I think it is in testing. So this is the VNR configuration. There will be there. So this is of if you enable VNR configuration. So if it is not available, that time you can disable it here. So now I think it is now in this release VNR will not be there. So if you are whenever it is available, that time if you enable this, and here you have to provide the MSI ID SDN. So this will be of the like last four digits of the SIM number, whichever the last like in the SIM identity you are giving phone number, right? That four digit number you can provide it in the MSI SDN. And once after creating this, you can click on the add sim. That particular sim will be created in this database. So this is for one sim card. If you are creating multiple sim, that time you can use the bulk sim here. So previously I shown you the for one sim, right? All this functionality will be same. Only one difference is you can enter the bulk sim. Like you can see the one tab called is there enter bulk. So how many bulks you want to add, that much bulk you can get here. If you are adding multiple, like around 10 bulk, 10 sim you are adding, that time you can give the 10. So the number will be whatever. For example, this is the one we are giving here, 01. So this is a starting number from if you are creating 10 bulk sim, that time the number will be starting from the 1 up to 10 number, it will be automatically created from the 1 series, 1, 2, 3, 4, like that it will create for up to 10. So like this the bulk sim configuration will be happening. And if you want to delete the particular MC number also, you can select the you can see the action button here, right? If this is the one sim is created, you can see action button. If particular sim if you want to delete, that time you can use this action button. And also you can see the once after creating, you can also view that particular details. You can see that this is the sim details once after creating one. And also you can view the sim slice details also here in the particular simc number. There is one action button called, so you can using that you can view, and also you can update the sim number, and you can delete the particular sim number also. If you want to delete bulk sim number, that time you choose this bulk sim number, and you can provide the from where to where you want to delete. For example, if you want to delete 1 to 10, that time you have to select the you have to give this from 0 to 1. Then how many bulk sim you want to delete, enter the bulk number. That time that much bulk number you want to like for example 1 to 10 you want to delete. That time this is the MC number of 001, and this will be of 10. So the 10 total of 10 sim number will be deleted. So if you want to delete all database, there is a all sim deletion of all sim numbers option is there. You can choosing that you can delete the all sim numbers. So this is of the all the configuration for the sim whatever it is there in the sim. So it according to the sim configuration only you are able to configure this sim details here. Hello, hello. Yes.
Yes, Manu. Yeah.
Can you take this analytics?
Okay. Actually, while we this is basically for that deep packet inspection. Like each session, how many in layer 7, how many Facebook or Instagram, what kind of app ID it attain, it will be show here. Currently, we not enabled the DPA in this deployment. So We don't need to be.
Maybe we need not cover this. Actually, this is an additional feature that is there, which we can. This is not part of the as a requirement in Fagilab, but maybe as part of some of the training we can just outline this. So I think Manu, we can wrap up this here, and
Okay, sir.
the next half an hour we'll utilize to go over the Wireshark before we probably will be closing for lunch, right? So you um, Sonuji and can we give presentation access to Venkatesh Neural Network?
Venkatesh
Yes,
neural
please.
network.
Wait.
Oh, yes, right given to him. Please check.
We are, we are unable to hear your voice. Hello.
Mute there. You can mute. It should be okay. You talk. That's fine.
No,
Hmm?
we
Okay.
from the mute.
You can
It's now I'm
update
audible.
the screen there. So we are audible.
Yes.
Yes.
Okay.
Okay, good.
This is the live pickup which we covered on one of that radio integration time. Here you can see that 5.58 is the IP of the Genode B and 5.120 is the IP of our AMF. And like the first two processors are the radio processors. Whenever the radio want to be attached with the core, on the time it will send the NG setup request. Like in this NG setup request, you can see that some of that IE is like what is the Genode B ID and then what is the PLMN serving by this Genode B. Like here, this Genode B will be serving the 00101. There is a test PLMN. And what are the tracking area code and slice supported by this Genode B will be come here by during the time of NG setup request. So followed by that, if this if the genome B, if this slice and PLMN is supported by this AMF, it will send the NG setup response. Else, like if it is not supported any of these PLMN or slice details, on the time NG setup failure will be happen. So this is a successful pickup. Here you can see what is the serving AMF name. That is a neural AMF, and it will share these AMF related parameters like global unique AMF identifier. These to identify the AMF. And followed by that, it will share that AMF capacity and whatever the slice and PLMN supported by this AMF will be shared by the AMF to the Genode B. So until this, radio and the Genode B will be sync up and it will be successfully attached. After that, followed by that, this is the registration request. Whenever you turn off your mobile, like it went from airplane mode to disable. When you disable the airplane mode on the time, it will first thing will
Sir, at
send the
which
registration
interface
request.
we need to catch this?
Sorry.
At which interface we had to capture this, and
This we captured
how
on
to
the
capture
N2.
this?
Yeah, this we captured on the N2 interface.
Can we select
This,
those interfaces manually? How to like how we don't know how to capture this?
Okay. Okay, Manu want to share this thing. That we will cover at last after we showing this
Sure, sure,
recap.
sure, sir.
I will cover that. Yeah. So followed by that, you will send the registration request. So in this inside the NGAP message, you can find the NAS. This is the actual N1 message. After it reaches to the G node B forward this same NAS message to that AMF. Here we can identify some of the IEs like what is the registration type, like this is initial registration. Same similar like emergency registration, service register, some more types of registration types also there. And one more important parameter here we can look that what is the identity of that mobile. Here it either it can send the GUI. GUI is the one of the like user equipment identifier. GUI stands for a globally unique temporary identifier, and sometimes it will send the TIMC also. Like it's already this UE was already serving by the same AMF. On the time it will either send the GUI or TIMC. If it is the first attached time, it will send that SUKI number. So Suki is the combination of that P element, that is the MCC, MMC, and along with the MC number. This is a totally 15-digit number. And followed by that, based on this 5G's mobile identity only, AMF will identify this user. And following by that, what are the service like security capabilities supported by the UE will be shared here. Here it will share both the like encryption algorithm and integrity algorithm it will share. Currently, this UE will support this like EA0 to EA3 and IA0 to IA3. These are the three things supported by this UE. And apart from that, it will share the user location information. Here, it will share that what is the tracking area code it is trying to attach and in which cell it is attached. So that are the details it will be shared here. And followed by that, it will share that RFC establishment case also in this during the registration request message. After this, once the registration request reaches to the AMF, AMF will talk to that AUSF. AMF will talk before that. If in either of the cases in the registration request, if you send the GUI or TIMC, if UE like that UE particularly that UE is not able to recognize by this AMF on the time, it will send the identity request. So after that, in the identity response, again you will send this Suki number. So this is also one case, and followed by that, AMF will talk to that AUSF for the AUSF auth service for the authentication procedure triggering. During this time, it will select the 5G AK authentication. Like in this pickup, you only listed the NGAP procedure, not the SBA layer. So after that, ASF will talk to the UDM and UDR, and it will get that authentication vectors. UDR will give the some of the authentication vectors based on the key OPC and authentication management field which we configure in our database. Based on that, it will query from the database, and ASF will followed by that key OPC, it will derive some of the authentication vectors. That authentication vectors will be used for that either the ciphering and integrity security also, and same for this SIM authentication also. Followed by that, like after AMF receiving that response from that AUSF, that is the expected response, expected authentication response. Then again, AUSF will ask you to challenge the authentication. So in this message, it will send the authentication request. This is again the downlink message. So here you can see some of the important parameters called as the random value, and this is the authentication token. Here the authentication token is the combination of the sequence number and the authentication management field and MAC. So based on these parameters, like SIM card, like you will calculate temporary response, it will share to the EMF in the uplink message. This uplink NAS message. So already earlier I said already AMF have an expected response that it get from that AUSF, and this is one another response. This is getting from that UE. So EMF will match with the both that response, one from the user and another from the UE. If both are perfectly matched on that time, it will go for the further results. So here the application response is successful and followed by that down in the downlink message, downlink NAS task message, AMF will send the security mode command. Here it will send the what are the security parameters will be supported by this current core network. So here we can see what are the security capability, encryption and integrity security capability will be supported by the core network. Here you can see. Our aim of currently support the encryption of EA0 to EA3 and integrity of IA0 to IA3. So these are the parameters. It will be shared to that UE over the NAS message, downlink NAS message. And following by that, UE will choose one of the integrity and we will choose one of the integrity and ciphering algorithm, and followed by that it will send the again the registration request in that after encrypting the messages. We by default we are preferring the null ciphering and integrity. So no message will be encrypted if it chooses either NEA1 or NEA2. On the time here we can't able to see the NAS messages. In the Wireshark, it will be show like your packets are encrypted. So for the debugging purpose, we always use the null ciphering. So here the registration security mode complete will be happen, and followed by that AMF will send the registration assert message. In this registration assert message, inside the NAS, we can see that what are the supported features for this particular UE. What are the network features supported for the particular UE. In this mainly we can see that IMS VOPs currently we disable this for debugging, and what are the features supported by the particular UE. Here we can go through. And followed by that radio will send that UV radio capability information, like what are the capabilities of this UV related to the radio. Either it may be that what kind of memo features it support and how much bandwidth it support. Everything will be shared over this UV radio capability. And followed by that registration complete NAS message will be come from that UV side. So here it will send the what kind of along with the registration complete message in this packet. You can see that one more uplink NAS message is there. That is a PD session establishment request also came. Like if you want to get any sessions, it want to access any internet or any other sessions it want to be attended, first it will send the PD session establishment request. So in that time, it will send the what is the data network domain network name it want to be get. Here it's requesting for the internet. This is the what we configure in the APN part of the SIM card in mobile, and what type of PDU session it want, and some more parameters related to that particular PDU session. It will send by the EU over the NAS message. And later by that, AMF will send the configuration update command. In this message, it will inform the what is the network name, what is the full network name. Here you can see. So it will give the Neural 5G. This is the network name. It will be finally reflecting on the mobile. At last, it will after that it will update the it will give the updated time zone of this particular core also. So based on that core, you will also sync up with this core. Once after this, AMF will talk to that SMF. AMF will select the SMF based on the slice and APN. And once the SMF is selected, SMF will talk to the PCF and get this particular session related policies. And SMF will from its dynamic pool, it will assign an IP to the UE, and SMF will talk to the UPF to make the one preview session. On the during the in the N4, it will exchange the PFCP session establishment request, and response will come between the SMF and UPF. During that time, it will share some of that rules like a forward action rule and packet detection rule, and some of the rules will be for this particular session how the UPF want to be handled. That will be informed by that SMF to the UPF. Finally, previous session establishment accept message will be forwarded from the AMF to the EV. So here we can see what is the aggregated maximum bit rate this for this session it allocated for this particular session, and what is the IP address assigned by this SMF, and what kind of slice it's chosen. Everything will be shared here, and what is the 5QA parameters, what kind of bearer it's the default bearer 5QA 9 chosen here. So these are the details we'll be sharing during the PD session establishment accept message. So apart from that, during the PDU session resource setup request, AMF will inform the N3 IP address of data plane side. This is the transport layer address of that N3. That means the GDP layer. So if any packets want to forward for this particular session, GNOB will forward to this particular IP address. That is the and apart from that, it will share the tunnel ID also. For each session, UPF will create a different tunnel IDs. One from the UPF side, and GNOB also will be create on the end. And at last, if the everything is successful, GNOB will send the PD resource setup response. This is for the only the this is the tunnel ID of the which tunnel ID on the end of that GNOB end, and this is the IP N3 IP address of the GNOB address. So these are the processes taken in the NCAP layer during the time of like GNOB attached with the core, and UE registration time, and following by that authentication will happen, and the PD session happen. This is the one complete flow of end-to-end flow of the UE attach. So if you after the data session is completed, if you want to remove that session on the time, it will send the PD session release request. In this, it will send that PD session ID. After that, SMF will release these resources, and followed by that, SMF will send the PD resource release command, and response will be PD resource release response will be sent by the GNOB again. So during this time, whatever the resources allocated during the time of a default or dedicated bearer, everything will be released by the GNOB. So this is the one end-to-end call flow. So this I like to show.
So, Sonuji, I think we can take some questions probably before anything specific is there.
Sorry, come again.
So, we are done with the explanation now, and
Okay, okay.
we can take some questions.
Sure. Yeah. So, hi team. If you have still any doubt regarding the core and this MEC and other things, so you can ask your query.
So this n gap is on N2, and sir was asking like how to actually expose it on Wireshark. Similarly, we can do this for RRC for N1, correct? In Wireshark.
Yes, we can capture. Manu, can you share your screen and one show how to capture this particularly N2 interface?
Okay, stop sharing.
Otherwise, I can get the index ID of it.
Hello.
Manu, you're there? Yeah.
Yes, sir.
You can share your screen.
They have to give permission, I think. So, Sonu's, hello?
1 minute, 1 minute.
Yes. Yeah, yeah. Whom I have to give presentation, right?
Yes, yes.
Yes.
Shiva.
No, no, Manu, she.
Manu.
Manusri. Okay, okay. Yes, right, given. Please check.
I want to log into the core VM.
Yeah.
No, this is your simulator, right? Can you go to that core?
No, no, this will be a code only actually.
Okay.
These two are SSH actually.
Okay. Manu, what is the N2 interface name? Can you check that? If conf, you can check that also.
Yeah.
Okay, here you can see 172.16. So what is that IPF N2? 172.16.0.5, right?
And this is yeah, N2 is 6, 0.6. 19.
16.0.6. Okay. Yeah, capture this. Go to the voice track and capture this interface. And only select the port number of 38412 and 2152. 38412 is the port number for NGAP. It will cover both the NGAP and NAS, and 2152 for the GTP. Yeah, only cover this, only capture these two both. Yes. Enter. Okay. NGAP, only add the filter for NGAP. Or attach the GNodeB and DUI again. Yeah, here you can see this how to capture this on particular interface. First, you need to know that what is the IP. Here it's IP is the 16.0.6. So that is lied on this ENP6S19 interface. So we are specifically capturing this particular interface along with the port number 38412 and 2152. 38412 for NGAP and 2152 for GTP. So here we can see all the N2 message flows in this pickup. Is any doubt on this? Is any questions on this one?
Yeah, Vinodji,
Yes, sir. Yes, sir.
clear or do you want to?
Yes, yes. It is clear, sir. Thank you.
It is clear. Any doubt?
So, sir, the command for knowing the N2 interface, N1 interface IP address, I could not understand like where it is written N1, N2 IP address. Please repeat for that.
If we export into enter IP address, nowhere.
No, that the latest release is not there.
Okay, by default we are configuring all the network. Manu, can you go back to that if config once? Actually, in all the 5G labs, 172.16.0.6 we are using for that
N2.
N2 and 172.16.0.5 we are using for the N3. So that is the default like IP diagram, IP architecture for our all the 5G labs.
Okay,
So
sir.
we will have any diagram. Later we can.
Yeah.
Later we will share that network diagram also. How the
Okay. So you go in the slide two, right, of our presentation, you'll find that. Um, so any have any more questions?
So I think Shivaji, all clear. I think you can move
Okay.
forward.
Yeah, so that's it from our side. So that we planned for around 2.5 hours in overview and some detail on the using the Wireshark.
Thank you very much, team, and please plan to update the same on all the institutions' new release version as soon as
Yeah,
possible.
sure. That we will plan starting tomorrow. We will update everywhere.
So once again, thank you very much, Niral team, for your support. And I would like to invite the Coral team for evolution board as per the time schedule.
Okay. Thank you very much.
From thank you once again. From Coral team, Naveen Gupta is there. Shoaib, please help to make a presenter, Mr. Naveen Kumar Gupta.
Naveen Kumar Gupta. Okay. Yes, yes. Wait. Yes, given. Please.
Thank you very much.
Welcome.
Naveen ji, over to you. Navinji, your voice is not coming, I think.
Please wait for 1 minute, sir.
Yeah, sure. Now.
Am I audible?
Yes, 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 Navinji.
Can we start?
Sure. Over to you.
Good afternoon to all. I am Naveen Gupta. I am from Coral Telecom, and I will present the training of the 5G Evolution Board. First of all, as you are seeing, I am going to tell you about the 5G Evolution Board, the component which is implemented on this evolution board. Uh, I hope you are able to see the mouse cursor position.
Yes, visible.
Yes, yes, yes.
Okay, so this port, this is the AT command port where you can run the AT commands. And one port is here below this. There will be another USB to C T-type port, USB 2.0, which is a debug UART. This position consists for the dual SIM connectivity. This is the audio codec card, the blue one. And this is the Wi-Fi modem. And upper this Wi-Fi modem, there is a 5G modem. And you can see here the antennas. Total 12 antennas are there. And this antenna is consists for the GPS. So this is the basic hardware architecture of the 5G evolution board. Besides this 5G evolution boards, here how we can start the 5G evolution board. How to do that? How to access the 5G evolution board and do the programming and check the debugging. First step is to start the 5G evolution board. How we can access this? We can access this via the MOBA XTERM utility. This is an open source utility. You can download it. What we can do? We can fire the AT commands. Number of types of AT commands are there, and the user manual is also provided for the AT commands. How we can register this 5G evolution board on the 5G network, and the use cases of the 5G evolution board, and how to troubleshoot the 5G evolution board called Anubhav. The model name is Anubhav. First of all, I am briefing how we can power on the 5G evolution board and what are the steps. Insert the private 5G SIM in the evolution board. Then power on the board using 5-volt adapter. When you will power on the board via the 5-volt adapter, that will only switch on the evolution board. That will not start the modems. To start the modems, there is a reset button. So press it for 3 to 5 seconds and leave it. After 15 seconds or 20 seconds, the board will boot entirely and will function. Then install the appropriate drivers to the computer. The recommendation is you can use driver booster and install the 5G 520F drivers and install the port drivers also if it is not there. Then you can take the access of the evolution board. Next one, how we can check on which port the evolution board is connected. So then go to the device manager and check there in the port setting, the COM port setting. Here also you can see on which port the evolution board is connected. Then after that, install the mobile extra. And now the steps to access the Coral Anubhav with mobile extra. On the top right corner of the screen, click it here. Another window will appear. Then you will go for the serial connection type. There will be 3 serial ports and the baud rate should be 115200. When you will connect, the Anubhav board will be connected. And to check this is connected or not, type the ATI command. That will show you the modem information. So you can reconfirm it. The evolution board is connected with your laptop. So here are some presentation. How we can do. Go to the session. Click on it. And then after click on it, there will be the speed baud rate and the serial board that I will show you in demo also live. And these are some basic AT commands. How to do the basic AT commands for further configuration or further debugging. For example, the first AT command, that is equal to question mark. So let's suppose the syntax is AT plus command, whatever the command is, and then the question mark. But it will show the command return the list of parameters and values range set to the corresponding write command or internal processes. And then there will be a read command also, just like the command AT plus command, whatever the command is, whatever you want to do to tech, and that will show you the queries. And there will be the write commands. Via the write command, for example, you want to set the APL. So you can do via this command, AT plus command, and then the value. Whatever the value is, 0 or 1, typically 0 or 1. Some command functionalities, some basic commands. Just for example, there is a ATI command. It will give you the model number and the firmware version. Another command is AT plus CIMI. That will give you the MC number. Another command is AT plus COPS. That will display the available networks. Or if you are using just like PLMN IDs 00101 text PLMN, it will show you. Another command is AT plus C fun is equal to 0. 0 means it will switch to the UE to the minimum functionality. Minimum functionality means typically it will restrict the network. So no network will come. And 80 plus C1 equal to 1, that will give you the all functionality. That means your modem will be connected to the 5G network. The next command is 80 plus CGD CONT. That will give you the APN list. And how can you give the APN name? Here you can see the 80 plus CGD equal to 1, then the IP, and then the APN name. For typically we use the two APN names. For internet connectivity, internet DNN, the APN name will be internet. Or if you are using IMS also, another command will be 80 plus CGDCONT is equal to 1, then IP, and then the APN name will be the IMS. The configuration of the Coral Anubhav 5G for the 5G registration only. So here you can see there are the 4 steps. First, set this network as a NR5G. Then the command will be the 80 plus QNW PERCFG mode per then NR5G only. So that will check only for the 5G frequencies, not for the 4G frequency or 3G frequencies. Then again, the APN name that will be set by 80 plus CGDCONT equal to 1, which I have told you earlier. And the most important thing is step number 3, the operator selection. If you want to do operator selection on automatic, then the command will be 80 plus COPS is equal to 0. And if you want to do Y manually, then 80 plus COPS is equal to 1. So you can select the network. And for the resetting or reloading the evaluation, I have told you earlier, 80 plus C1 is equal to 0. That will restrict the functionality, that will disconnect the 5G network. And 80 plus C1 is equal to 1. That will give you the full functionality. So the evolution board will connect to the 5G network. And here is the use case. How we can connect the Raspberry Pi or your sensor box. Typically the sensor box which is provided with the evolution board. So USB connectivity is also provided, and USB will be also present in the MCU, the microcontroller unit. This use case explore the practical application of automation, the configuration of the 5G evolution board using bash scripts on a Raspberry Pi or whatever the MCU board you are using. By leveraging predefined commands, user can efficiently manage network registration, modern setup, configuration change without manual intervention. How we can do that? We can take the access of the evolution board without connecting evolution board directly to the laptop. You can also control the 5G evolution board via the MCU also. What it can do? This automation enhance reliability, speed up development, and reduce human error in the 5G connectivity setup, making it ideal for the IoT applications, industrial automation, research project. The guide provides a step-by-step approach to executing 80 command via Bash, ensuring seamless interaction between the Raspberry Pi and the 5G modem. what are the prerequisites to connect the MCU board to the 5G modem? Then number one, for Raspberry Pi, any model, but USB support should be there. 5G evolution board, SIM cards, Minicom, that is a serial communication tool. If it is not there, then you can download it or install by the sudo apt get command, apt get install Minicom and USB to serial driver. If it is not installed, please install it. And then the setup instruction. So you can see here the command is device TTY USB. This is the required package. If it is not there, then install it by this command sudo apt update and then sudo apt install -y so ca8. It is just similar to the serial port. And please grant the every permission chmod 777. These are the basic scripts that will give you the control of the 5G evolution board through these commands. In later stage, I will explain you how to run the script, and then there will be a troubleshooting. So how do the troubleshooting? First of all, check the power connectivity. It should be connected to the 5 volt adapter, and the SIM card should be installed properly. Drivers and firmware verification. Whether you are using Linux or Windows, the driver should be connected and driver should be installed properly. If it is not there, then it will not connect. And check the AT commands. And remember that the default baud rate is 115200. To check it is connected with your laptop, the command is ATI. That will give you the info, manufacturer info. And other command is AT plus CGMR. That will give you the firmware version. So that how you can ensure that the evolution board is connected with your laptop. Some other debugging logs. Let's suppose the modem is not booting. So you can connect USB to Type C on the debug UART port and switch on the evolution board via the reset key. The baud rate should be 115200. That will give you the entire boot up process. Entire boot up process, you can see where the evolution board is stuck. That will prompt you. Again, the firmware and device information, the command will be AT plus CGMR. For MIMO configuration, there will be a command. And if MIMO is not configured, so you can enable it by the last command AT plus QNWCG 5G MR MIMO and enable 5G MIMO. So I'm going to the live demonstration. First of all, connect the evolution board to the laptop. and go to the session. Then there will be a tab of serial. Go to the serial and check here. So there are three commands, one for the AT, one for the DM, and one for the NMEA port. So we have the access only the AT ports. So select it from here and get the speed, the baud rate 115200 and press OK and check whether it is connected or not. ATI. So you can see here the manufacturer detail and the firmware version. So you can see here the uh, evolution board is connected with your laptop. Some commands are also there. For example, please give me a second. How to check the APN list. So here you can see the four APN is set: one for internet, one for IMS, one for OSS, and one for XCAP. For example, how the operator list. PLMN is 11. This is a text PLMN 001 and 01. 001 is the MCC and 01 is a mobile network code, mobile country code plus mobile network code. You can also check the current signal info. So you can see here the 5G evolution board is connected on the TDD band and it is connected on the NR5G. This is the PLMN. Band is 78 and this is the ARFCN number. Also, you can check the RSRP. RSRP value. And again, airport mode on or off. If you will do the AT plus CFN, the R and result will be okay. So this evolution board is disconnected from the network and the AT plus CFN is equal to 1. You can see here I made a wrong command. It is giving the error. And if I am putting the right command, that will give you the syntax error as syntax as a okay. I think Vishnuji, this is disconnected from your laptop.
1 minute, Navneet. Let me check.
Okay. Okay, sir. This is connected. Give me a second.
Yeah, please check Naveen ji.
So here you can see the 5G evolution board is connected with the laptop. So these are some commands, 80 commands. If you want to do only IPv4 setting, make this command. And if you have the IPv6 connectivity also, so you can set the APN for the IPv6 also. And this command to check the IP address.
डिटेल्स आ गए आपकी, पर आप उसको रजिस्टर तो करोगे.
Okay. No problem. So why these 80 commands? Just I am giving you the basic 80 commands to check the connectivity. Further, for more 80 commands, there is a document which is also provided to VVDN. So you can refer this document for the further 80 commands. Wait. Further, my colleague Abhishek will tell you the read and write commands.
Good afternoon to all of you. Let's start. Where is the PPT? Wait 1 minute. What is the 80 commands? How can you use it? बेसिकली अगर आपको मॉडेम में कोई भी कन्फिग्रेशन चेंज करनी है, उसके लिए हम 80 कमांड का यूज करते हैं. अब 80 कमांड तो बहुत ढेर सारी हैं, पर आपको उनका सिंटेक्स समझना पड़ेगा. सिंटेक्स कैसे है? जैसे सबसे पहले हम सिंटेक्स समझते हैं टेस्ट कमांड के बारे में. अगर आपको किसी कमांड का टेस्ट करना है, टेस्ट का मतलब ये है कि उसकी पैरामीटर वैल्यू क्या है, पैरामीटर्स क्या है, वैल्यू क्या है, आप क्या असाइन कर सकते हैं. तो उसके लिए जो सिंटेक्स है वो आप अपने स्क्रीन पे देख पा रहे हो. मैं हाईलाइट कर रहा हूँ. अच्छा, कर्सर पे नहीं हुआ. ठीक है. हाँ, मैं आपको टर्मिनल पे दिखाता हूँ. 80 प्लस QNWCFG इक्वल टू क्वेश्चन मार्क. हाँ, बेसिकली ये क्या है? टेस्ट कमांड है. मैं आपको एक्सप्लेन करता हूँ कि चीज़ें कैसे रन की जाएगी. इसमें क्या है, 80 के बाद हमने कमांड यूज किया QNWCFG, नेटवर्क कॉन्फ़िगरेशन की कमांड, जिसके थ्रू हमने क्या देखा कि क्या क्या पैरामीटर हम यूज कर सकते हैं. LT के लिए, NR5G के लिए, सेल आईडी के लिए. तो ये इसकी पैरामीटर होगी. इनके साथ हम वैल्यू क्या असाइन कर सकते हैं. 0 और 1. 0 मतलब ऑफ करना, 1 मतलब ऑन करना. द सेकेंड पैरामीटर इज फॉर सेविंग इन विच मेमोरी, परमानेंट मेमोरी या रैंडम मेमोरी. Just show you like a 5G MIMO enable or disable command for 5G and 4G also. These are for 5G. This one.
सर अभी बोर्ड में जो सिम है ना, वही वो
हाँ,
वो पब्लिक सिम है कि वो 5G लैब का ही सिम है, आपने जो डाला है उसे?
सर
प्राइवेट सिम है अभी तक। अभी
हाँ
आपको
हाँ।
दिखाया था ना, जो एपीएन की सेटिंग दिखाई थी, जहाँ पे हमने वो दिखाया था कि कौन
ओके
सा
ओके।
पी11 आ रहा है, तो उसमें 00101 आ रहा था, तो ये
यस
पब्लिक
यस।
सिम था, प्राइवेट सिम।
ओके ओके।
मैं कुछ कमांड बता रहा हूँ सर। जैसे आपको अगर रिलीज पता करना है कि रिलीज कौन सा है, 3GPP रिलीज, तो पहली बात तो आप टेस्ट कमांड से क्या है कि क्या क्या चीज़ें आप चेक कर सकते हो और उसके लिए क्या क्या वैल्यूज हो सकती है, मतलब डिफ़ॉल्ट पैरामीटर्स क्या है और डिफ़ॉल्ट वैल्यू क्या आप यूज कर सकते हो। बेसिकली हर कमांड के साथ क्या वैल्यू आप दे सकते हो, क्या पैरामीटर्स यूज कर सकते हो, वो है। अब जैसे अगर मुझे एपीएन वाली कमांड चेक करनी है, हाँ, तो ये रहा एपीएन डिफाइन करने की कमांड। तो इसको मैंने रीड कर लिया कि आप क्या क्या यूज कर सकते हो। जैसे आईपी टाइप यूज कर सकते हो, IPv वर्जन 6, IPv4 वर्जन 6 यूज कर सकते हो। इसके बाद नेक्स्ट आएगा आपका रीड कमांड आएगा। रीड कमांड, तो रीड कमांड का सिंटेक्स क्या है, आप कमांड के बाद अगर क्वेश्चन मार्क यूज करते हैं, जो उसकी करंट वैल्यू है, मॉडेम की उस कमांड को लेकर जो कॉन्फ़िगरेशन की डिफ़ॉल्ट वैल्यू है या जो करंट वैल्यू है, डिफ़ॉल्ट नहीं करंट वैल्यू बोलेंगे, आप उसको देख सकते हो। जैसे 80 प्लस CGD पॉइंट क्वेश्चन मार्क। तो जैसे पहला जो है आईपी पे जो पहला एपीएन इंटरफेस डिफाइन किया गया है वो आईपी में इंटरनेट दिया गया है, और सेकंड क्या दिया गया है, IPv4 वर्जन 6 पे आईएमएस दिया है। ये भी करंट वैल्यू है। तो रीड कमांड से आप किसी भी कमांड की करंट वैल्यू को रीड कर सकते हैं। जैसे और डायरेक्ट अगर एग्जीक्यूट करना है कमांड, तो आप कमांड के साथ ना इक्वल टू यूज करेंगे ना क्वेश्चन मार्क। जैसे मान लीजिए आपको इमसी नंबर जाननी है, सॉरी जस्ट this is the MC number of the SIM. You can see this is a private SIM.
You can see here the first 5 digit 00101. That is a private PLMN ID.
Next is I think write command. The last syntax is a write command. How to write things. If you want to configure some configurations in modem, how can you write? Uh, just there is the move extra. अब जैसे मैंने क्या किया है, प्रीवियस कमांड में मैंने एपीएन डिफाइन किया था इंटरनेट। अब मैं इंटरनेट ना डिफाइन करके मैंने कुछ और डिफाइन कर लिया, मैंने अपना खुद का कोर बनाया, उसमें खुद का एक एपीएन डिफाइन कर लिया किसी भी XYZ नाम से। तो मैं उसे राइट कैसे कर सकता हूँ मॉडेम लेवल पे, मैं एपीएन कैसे कॉन्फ़िगर करूँगा। तो सबसे पहले हम कमांड यूज करेंगे। अब मुझे किस इंटरफेस पे यूज करना है, मान लीजिए मुझे 2 पे यूज करना है, एपीएन इंटरफेस 2 कॉमा, अब मैं IPv4 वर्जन 6 पे ही यूज कर रहा हूँ, तो डबल कोट में सिंटैक्स आप ध्यान दीजिएगा। एक मिनट, ये क्या हो गया? अच्छा वो कमांड, वेट 1 मिनट। 80 प्लस CGD कॉन्ट, सॉरी इट्स रॉन्ग टाइपिंग, CGD CONT इक्वल टू 2 कॉमा, हाँ जो ये पैरामीटर वैल्यू दिए हैं हमें वैसे ही यूज करने हैं। IPv4 वर्जन 6 कॉमा, अब जैसे यहाँ पे IMS है, मैं कोई और XYZ यूज करता हूँ फॉर द एग्जाम्पल पर्पज। एपीएन बेसिकली स्मॉल लेटर्स में होते हैं। द रिस्पॉन्स इज ओके। नाउ बाय यूज ऑफ टेस्ट कमांड यू कैन टेस्ट which write the value is written or not. 80, sorry, caps में 80 plus CGD CONT equal to question mark, oh sorry current value रीड करनी है, T question mark. You can see here the parameter and the value is changed from IMS to XYZ. So you can configure multiple APNs by using this. And next thing, wait. हाँ, wait. It's my screen. Where is my screen? These are the basic commands. Okay. Okay. हाँ हाँ नेक्स्ट पॉइंट इज रास्पबेरी पाई यूज केस विथ कोरल अनुभव। कोरल अनुभव के साथ आप कोई भी माइक्रो कंट्रोलर बोर्ड लाइक रास्पबेरी पाई या अनदर बोर्ड यूज करके कैसे यूज केस जनरेट कर सकते हैं। बेसिकली इस यूज केस में हम आपको क्या बताएंगे कि आप कैसे कॉन्फ़िगरेशन को ऑटोमेट कर सकते हैं। अभी तक क्या है, आप एवोल्यूशन बोर्ड से एक लैपटॉप या एक पीसी कनेक्ट करते हैं, फिर उसके बाद मोबाइल एक्सटेम के थ्रू उसमें कॉन्फ़िगरेशन चेंज करते हैं। ये सारे काम आप बैश स्क्रिप्टिंग के थ्रू एक रास्पबेरी पाई यूज करके भी कर सकते हैं। जिसके लिए प्रीरिक्विजिट क्या है, रास्पबेरी पाई होनी चाहिए आपके पास और कोई भी डेबियन बेस या उबंटू बेस ओएस होना चाहिए, 5G एवोल्यूशन बोर्ड होना चाहिए, सिम कार्ड बेसिकली रिक्वायर्ड, ठीक है। और हाँ, मिनी कॉम और अनदर सीरियल कम्युनिकेशन टूल। बेसिकली मोबाइल एक्सटर्न आपके विंडो के लिए है। आपके रास्पबेरी पाई में लिनक्स का कोई वेरिएंट पड़ा होगा तो उसके लिए आप मिनी कॉम यूज कर सकते हैं या सोकैट है, अनदर सीरियल कम्युनिकेशन सॉफ्टवेयर कोई भी आप यूज कर सकते हो। और ड्राइवर्स बेसिकली उबंटू और या डेबियन के ड्राइवर सपोर्ट डायरेक्ट होते हैं, विंडो में आपको इंस्टॉल करना पड़ता है। नेक्स्ट स्लाइड इज हाँ तो आप कनेक्शन कैसे करेंगे, मैं सबसे पहले कनेक्शन बता देता हूँ। पहले तो आप एवोल्यूशन बोर्ड को चालू करेंगे, एक सिम लगा लेंगे, फिर इसके जो मेन टाइप सी पोर्ट है जो बेसिकली 80 पोर्ट के लिए यूज होता है, उससे कनेक्ट करेंगे रास्पबेरी पाई को, ठीक है। और रास्पबेरी पाई का आप एक्सेस पहले ले लेंगे इथरनेट पे और वहाँ पे आप चेक करेंगे कि यूएसबी कनेक्टेड है कि नहीं। कनेक्टेड है, इसके लिए हम कमांड यूज करते हैं ls/dev/tty/usb*. Then press enter. You see the ports, basically the USB port which is acquired by evolution board. The default port is /dev/usb2 for the 80 port. Next, please provide the permission to USB using this command sudo chmod 777/dev/tty/usb*. Basically, all the ports give the permission to read, write, and execute for all the users, groups, and others. Next, okay, this is the next point. This is the bash script which is used to automate the configuration of evolution board. So in bash script, please create a file.sh extension like modem_config.sh. You can see my screen. I highlight it. This. So you can create any .sh extension file, then write some commands. The first line is #bin/bash. Basically we are providing the path of bash. जो टर्मिनल पे जो सेल यूज हो रहा है उसका पाथ हम डिफाइन करते हैं। इसके बाद इसमें हम ये चेक करते हैं कि आपके पास सीरियल कंसोल सॉफ्टवेयर है कि नहीं। तो उसके लिए हमने इफ एक्सक्लेमेशन कमांड -v सोकैट और इसमें हम चेक करते हैं अगर ये कमांड अवेलेबल है तो सोकैट इज नॉट इंस्टॉल, मतलब अगर इंस्टॉल है तो ये और इफ कंडीशन के बाहर आ जाएगा। अगर इंस्टॉल नहीं है तो सबसे पहले ये जाके अपडेट करेगा रास्पबेरी पाई को, इसके बाद सोकेट को इंस्टॉल कर देगा। इसके बाद नेक्स्ट पॉइंट यहाँ पे आता है, एल्स में तो ये है कि स्क्रिप्ट स्टार्टेड। द नेक्स्ट पॉइंट इज द कमांड रन एंड आउटपुट शो इन फाइल। अगर आपको किसी फाइल में आउटपुट को शो करना है तो इसके लिए सबसे उस फाइल के अंदर हम क्या लिखेंगे जो modem_config.sh है, echo ATI socat/dev/tty/usb2 crnl greater than equal to temp/hello। तो जो ATI कमांड का रिस्पॉन्स होगा वो आपके टेम्परेरी फोल्डर के अंदर एक हेलो नाम की फाइल होगी जिसमें सेव हो जाएगा। ऐसे ही एक नेक्स्ट कमांड है सीन फाइंड करने के लिए, वो भी इसी फाइल के अंदर अपेंड होती जाएगी. द थर्ड थिंग इज नेटवर्क कॉन्फ़िगरेशन कमांड. The output will be saved in /temp/hello file. Basically, in temporary directory, there is a hello file in which all the outputs will save. When you want to append the output, if you want to append, like at which time what are the commands and what are the output or response values, so you can use append command. The command is same for network configuration and socket USB to select किया 80 port basically, and here we use twice of greater than symbol. Basically, it is used for append in Linux. This symbol is used for append in any file. So the output will append in that file. If you run 4 commands, all the 4 commands response will append one by one. For print on file and terminal, if you want to print the output or response of the command in terminal as well as in file, so you can use echo ATI, like finding the manufacturer details, and so get then tree/temp/hello. This will print the output in the terminal and write in the hello file. Read command through the file. If you want to read the 80 commands through a file, if you define to read a command through a file, you can write the commands in any text file like command.txt. If you want to, you can change the name. By using this syntax in the command, you can take the input from a command file and write to a terminal or a file. The whole command is used in bash script file. After creating the file, you want to make it executable. Basically, it's a .sh file, cell file. So using the chmod plus x modem underscore config.sh used for give the executable permission to that file for all the users, normal user, group user, and others. Then you can run this file using sudo space dot slash modem underscore config.sh. The script will run. If you want to make it by default enable, so you can make a service also. To make a service, you want to create a dot service extension file in /etc/systemd/system. In this folder, you can write. The syntax is for the service file is here. The unit. Basically, we are describe what is the service and why it is used. Next is service. The main thing is execution start. Basically, exec start. Basically, we define the path of the terminal, basically bash terminal, then the path of the configuration file. There is the configuration file. Restart always means if any problem, it will restart automatically. User permission will root. Installed by multi-user target. Wanted by multi-user target means any user can run this service. Save file at this location, this dot service file, and run the following command. बेसिकली आपने एक सर्विस बनाई है, अब आपको क्या करना होगा, डेमन रीलोड करना होगा. सारी सर्विसेज को आप रीलोड करेंगे. और अगर आप चाहते हैं कि हर रीस्टार्ट के बाद ये स्क्रिप्ट ऑटोमेटिकली रन हो जाए, तो इसके लिए आपको क्या करना होगा, सर्विस को ऑटोमेट करना होगा. ऑटोमेट करने के लिए ये कमांड है, आई एम हाईलाइटिंग वेट, दिस कमांड sudo space systemctl enable space modem underscore config dot service. By use this, you can automate the service. The description is enables the service to start automatically on boot on every. Okay. For start the services, the command is sudo space systemctl space start space modem underscore config dot service. Start the service immediately without rebooting. The next point is troubleshooting of Coral Anubhav. Basically, it is required for the primary level to check the all the connections are proper, drivers and firmware are proper or not. If you want to use the evolution board, you want to require proper power and proper connection with appropriate drivers and some basic AT command information to use it. uh, Debugging logs, there is a debug port, basically a type C port which is used for debugging, which is in front of the evolution board, type C port. When you connect with that cable, a type C cable with the USB debugging port, you can see the port name, this highlighted name. By using this, you can take the access using baud rate of 1152. You can use mobile extern or putty for this, by which when you start or off the evolution board, you will see the logs at the boot up types, which service is enabled, which service is off, which key codes are used, and which firmware version and revision version are used. These are the some basic commands to see the details of firmware and device information, MIMO status, and how to enable MIMO. The last point is troubleshooting of Coral Anubhav from the ADB. It also acquires Android, so you can take the access by using main type C port, which is also used for AT port. You can take the ADB. Using the ADB, you can access the services and see the what are the services are running. If you want to change the services, you can use it. If you have the OS access, you can do anything at OS level. By default, you are accessing by a root user when you use the ADB. This last command is used for C for all the services which is running evolution board. Okay, I think that is complete. So I am from my side. It is complete. Now I am. Any query? If any query, you can ask. Raise the hands.
Yes, Shania ji, you raised a hand. Just ask your query or do on a public chat.
Yes, sir. I got your question. or your query. When we try to connect on the Windows platform, it runs smoothly, but using Minicom on Linux, it is not. So basically, you want to connect on USB to port 2 slash dev slash USB 2 and use ATE command. ATE for attention command echo mode. When you use in Minicom, by default the echo mode is off. So you are writing any command, the command will not see by you. You only see the response. I think that is the main problem from your side, which is I am understanding by your chat. Yes, sir. So you can use first when you accessing the Coral Anubhav or Evolution board by using Minicom. You can use first command is ATE, which is used to enable the echo mode of the keyword. I am also writing in your public chat. You can see the command.
Any other query?
Ayush sir, you can also use SOCAT also, which is also a civil console software. No, no, sir. It's not lagging in the Linux. Basically, you want to use a specific port, which is 80 port. Then use the appropriate command for its use smoothly. We also use in Linux. I am using an Ubuntu 20. It's working very fine. And also tested on Debian versions like Debian 10 and Debian 12. It worked very fine.
Hello, Naveen sir. Naveen sir.
Yes. Yes, sir.
This basically when you type this ATI command, I have seen that it is basically from the QTEL, right?
Yes,
Yes.
This
sir.
evaluation board.
Yes,
Yes,
sir.
sir.
Now, is it possible to have something customization related to RFID or NFC tags? On is there any provision is there on this evaluation board?
Sir, you can refer the document, 80 document you have provided by the VVDN. You can
Oh,
check the what are the configuration you can configure at the modem level. If you want to change something in OS level, you want to take the access of ADB, Android debugging with, by which you can change the service level. You have the all the access at OS level and modem level. So using the AT commands, you can do it.
Actually, there is almost 1,000 commands of 80. So you have to read the document. Whatever you want to change, you can change it.
okay. Okay, thank you.
There are two USB ports are available. One is USB 3.0 and one is USB 2.0. The main port is of 3.0 and
And also support USB 2.0.
it also supports the 2.0. Any other question? Vishnu sir, I think there is no lot more questions. So we can conclude it.
Yes, yes, yes. Anyone have if anyone having any question, he can ask, or if everything is clear, so we can wind up
Go
this
for the
session.
lunch.
So I am concluding this session now. If any query is there, please write a mail to us. We will rectify your problems. Okay. Thank you.
Okay, thank you once again, the Coral team, and thank you for all. So now we will come back after 3 p.m. So take your lunch till 3.
Thank you very much.
Thank you once again. about the drone. So I would like to invite Anup. Over to you.
Okay, sir. Uh, Thank you so much, sir. I am Anup Elawat, and I will with you regarding the drone training and the drone operation. So before going forward, so I would like to introduce the what's the hardware you are having in your lab, and before starting flying, it's better always to know your hardware, know its capabilities. Just a second. Yeah, so I'm loading a 3D model of the drone that will look like this. So this is the Superna drone you are received in your lab. So it is basically a quadcopter of having four motor, and it has a various sensors. So when you're looking at the drone, so from the front, the top mounted sensor is basically a vision sensor, and the top sensor is basically a vision sensor, and the under the vision sensor, it's a camera payload. From the bottom of side, the drone has a downward facing vision system, and at the back of the side, the drone is equipped with a rangefinder, centimeter level precision rangefinder. Most of the things are inside the drone, like flight controller and the companion computer. The drone battery is mounted from the upside and need to be pushed once to insert properly. So this is the all about the drone, and before going further, I would like you all to read all the manuals regarding the drones for this safe operation. So how you can access the manuals regarding this particular product. So this drone is powered by idronum.com platform, and you can go to the idronum.com and visit the resource section. And after the resource section, you can choose your product, which is basically a Superna 5G. Superna 5G product, and scrolling a bit down, you will see a user manual, flight manual, charging manual, C2 manual, and the indoor flight consideration manual. Landing replacement guide in case the landing gear is damaged during the transmission or of the drone, so you can replace it at your premises. The processing specs document the detailed processing specs of the onboard computer and the payload flight consideration when you are flying a drone equipped with the payload, and the particular training document for more enhanced version of training. So these are all the manuals that a user need to be read before proceeding further with the flight, and it's always, just give me a second. Okay, sorry. So these are all the manuals regarding, and before going further, we would go deep detail into the technical. Just a second. So before going into the technical details, you need to before going to flying the drone, you need to be handy with all the technical specification, what your drone is capable to do, and what not to do. So these are the user manuals. So I have a copy of my user manuals, so we will read the user manual first. So the manuals are kind of well equipped and well maintained, so you need not to go out. Most of the details are covered in the manual itself, and you can have all the things in the manual. If something is still left which is outside of the manual, so need to be covered in the manual, feel free to contact us. We will add that particular thing in the manuals. So how the aircraft look like, so we will first read the aircraft diagram. How so you will get a better estimate how the sensors are mounted, what are the parts that combine together to form a drone, and the sensor that are on a body or chassis of the drone. So drone has propellers, vision system, downward facing vision system, rotor arms, rotors, landing gears, and battery. So these are how battery and the things are equipped. And regarding the more technical specification about the drone, so drone is type of a quadcopter. The frame material is a carbon fiber, which has a propeller to propeller size, means center to center distance of the propeller is 470 mm, and the drone without carrying extra payload, including the battery, the weight is around 1300 grams. So it's a enough bulky drone to have flying in a very restricted area, specifically the indoor environments. You can attach the extra 500 gram with the hooks that has been attached to the drone body. The drone can operate the max outdoor altitude of 50 meter. So this 50 meter is restricted with the bare minimum altitude that is allowed to fly the drone. This is not the maximum altitude that the drone supports. To get about your local area, to get about your environment or the local rules and regulation, we would recommend to visit digital sky platform. So this digital sky is basically a Indian aerospace map. So which particular zone is a red zone, or which particular zone is a yellow zone, and you can see the airspace map in the reference. This map is dynamic in nature, and pilot need to confirm its local rules and regulation before flying the drone. So right now you can choose any particular position. Like I will go with Chandigarh. So Chandigarh is basically having an airport. So this red box is a red zone, then the yellow zone, and then the outer yellow zone. So this is the scenario of flying a drone in Chandigarh. So right now we are in a this yellow zone. So you have some rules and regulation for research project as well as for the commercial usage of drone. So while you are flying the drone, this is a research purpose drone, and you have to always look for the rules and regulation that is applied for the research drone, not a commercial drones. And it is always recommended not to fly the drone beyond 30 meter in any of the zone if you having a research kind of drone. Yeah. The drone supports low battery failsafe, the critical battery failsafe, and the ground station connection loss feature. So these behavior can be tuned by the pilot. Also, what will happen when a low battery is triggered? What will happen when a critical battery is triggered? What will happen if your connection to the drone is lost in some case? Then the drone have some indoor features with a 360-degree obstacle avoidance system, vision-based odometry. So in the vision-based odometry, you need not to have a GPS to fly the drone to maintain its position. And the indoor precision hold is supports up to 10 centimeter. Drone supports real-time video streaming, and you can visualize the obstacles in 2D and 3D space. Drone is internally equipped with the ROS support, ROS 1, and 5G features, so N78 band. So drone is specifically logged for your N78 band for the 100 5G use case. So drone inside the private network, you are able to latch the drone only on N78 band. Drone supports multiple bands, but for the private 5G or 100 5G project, your drone is only restricted to the one band, which is N78. Drone has a lithium-ion 4-cell battery, which has a capacity of 4500 mAh, and under the safe procedure, it can charge and discharge 300, complete 300 charging cycle and complete 300 discharging cycles. So drone supports 18 minutes in an unrestricted environment like a normal wind condition. Drone supports 18 minutes without any extra payload. Cruise speed for the outdoor, the drone speed is at 54 km per hour maximum for this particular model, Suparna, and indoor is 15 km per hour. We have further restricted these speeds in indoor and outdoor environments, since because most of the labs are not they are going to be the first flyers, they have never fly the drone before. So for keeping the safety in mind, we have further reduced the speed, so you are going to operate this drone at a 10% of its actual capacity. Once you are familiar with the drone, once you are a trained pilot, Once you have enough knowledge about your environment, so you can contact us and we will kind of unrestrict these values, and you are able to use Suparna drone at maximum capacity. Communication channel right now, the phone supports both 5G and Wi-Fi 6. So regarding the Wi-Fi, we will demonstrate flight on Wi-Fi as well as 5G. GCS. So the drone you have equipped is comes with the iDronem for enterprise software, which is specifically designed for private 5G labs or captive networks like 5G or 4G. But in this case, in this lab, we are going to talk about the 5G. GNSS. So drone support GPS, L1 and L1 band, BiDU and others only on L1 bands. So hovering accuracy, vertical 0.2 meter with position vision positioning, plus minus 1 meter with GNSS positioning and barometer. Horizontal, it supports plus minus 0.3 meter with world vision positioning and 1.5 meter with GNSS positioning. Operating temperature, since drone is equipped with an onboard computer which heats when it's forming a 3D map and doing other scenarios. So the operating temperature, safe operating temperature of a drone is 5 to 40 degrees Celsius. Vision operating environment, since vision system of the drone is working in the same manner like a human vision system, so it generally don't it fails in some conditions where the diffuse reflexivity of greater than 20% and the adequate lining is less than 15 lux. If it's pitch dark, then it is recommended not to use drone vision system, not to use obstacle avoidance. They can perform the misreadings. It is always recommendable to have a sufficient visible environment for the vision system to operate. Image sensor, so drone comes with 1 by 2.7-inch 2MP effective resolution, high field of view, which is around 160-degree FOV, and you can control the drone cameras and pitch angle by -90 to 25 degree. You can make the camera look perfectly 90 degree down to the 25 degree tilted up, pitch up. And again, so this is all about the technical details that a drone you have received is equipped with. And most of the things are always mentioned in the manuals, but there are some kind of things that you need to target before reading this manuals. We have provided the legends how to read. So these are the warnings. These are when you see this sign, so this is a warning sign, and you never need not to attempt that particular usage of the drone. And this is the important, this is a pilot need to remind when flying the drone. These are hint and tips. If there's a kind of short tricks or tips that pilots need to remind for the safe operation. There are the references. If the drone, if this particular manuals refer the some use cases out beyond this manual, so the references are always mentioned there. And I forgot one thing, that when you are looking at the iDrone, so we have the video tutorials, how to take indoor flights, how to take outdoor flights, and how to do pre-flight checks. So we recommend users or the pilot who are going to fly the drone to read all the manuals, all the tutorials on this website and on our YouTube channel. If we update our software, if we update our tutorials, if we update some kind of thing, so you will receive the notification via mail, or you will find a video on the YouTube to see what the changes are, kind of a release guide. So what feature we have moved to which location, is there any operating change for the pilot to remind of. And always remember to keep track of your space and the government notification regarding your zone for flying the drones. So this is some sort of a quick intro about what we are going to perform. And this manual illustrates the safety precautions. The safety precautions are always mandatory for a pilot to follow before flying the drone. So operating a drone is always a critical task. So you have to keep on every part, every change. If there is something that confused you, feel free to contact us.
there is nothing we can resolve at our end, but do not create mistakes, do not create mishaps, because when the drone is flying, it's around 1.5 kg body hanging in the air. So it's always up, and at the end it's a machine, so the parts can create a mishap. So it is always recommendable to have a safety guidelines before flying the drone indoor as well as outdoor. Do not fly the drone at some other private spaces. Have the drone in your research arena. So drone contains the safety precautions of pre-flight checks, like you have to inspect the drones for any mechanical or physical damage. Ensure all software and firmware are up to date. If the iDrone software give a pop-up to update the software, please update the software first, in case we have fixed some bugs or introduce a new feature that makes the pilot more accessible to the drone. Check the battery level. Never fly the drone with a half charge battery or the no charge battery at all. Charge the battery adequately. You have provided with a charger, and in case you have received a Wi-Fi charger, so you have received a Android app regarding the same, to install the app and monitor the battery. Regarding the charging of the battery, so charging a drone battery is always a critical task, and again, as per the DGCA rule, it's need to be monitored. So please always charge a battery in front of your eyes, in front of your presence, and never leave the battery unattended. So environmental awareness, there are some kind of aptitude we are expecting from the pilots. So like clear the area of the people's pets and fragile object to minimize risk. Be aware of in space layout. Never move the drone in some areas which is not accessible to you and you are not aware of. Avoid flying near air vents or any kind of AC vent. So always fly the drone in a adequate space where that some external air is not interfering with the drone. Control and supervision. So pilot control and supervision is always healthy discussion. Always maintain a visible line of sight with the drone. Do not rely on the drone cameras and sensor. Use visual supervision. And these guidelines that we have illustrated here, these are pretty ensured as per the DGCA rules and regulation for flying the drone. These are not something that we have comes with the hardware of Superna, but these are comes via international laws, international flying operating procedures. So these are the guidelines that we have adopted from kind of already maintained architecture. Use of the safety feature, drone obstacle avoidance to prevent collision, and the engage geofencing if you are flying in a restricted airspace. So please geofence the drone with a valid geo points, and always enable the geofencing so that the drone never moves out of those boundaries. Speed and height measurement, always have a visible check on the drone height as well as on the sensor reporting height. If they mismatch, land the drone and follow in case the sensor is misbehaving, because 5 to 10 meters is not a critical height, but when you are flying a drone at 50 meter, 100 meter, 200 meter, so misbehaving in altitude can cause damage. Interference consideration. So as you are having a 5G drone, so it is susceptible to the interference from the other source, like a nearby tower that is radiating the N78 band at the full capacity, because since we are having a very limited capacity in private 5G labs, so be aware of any potential interference. If you feel any interference is there either in a 5G or Wi-Fi, so do not proceed with the flight. If you are only confident that it's only a if you find an interference in a N78 band, fly the drone with Wi-Fi. Do not force the drone to fly in an interference area. If you find an interference in a Wi-Fi, then you can fly the drone over the 5G. If you are finding an interference in both the interfaces, then please change the location. It is always recommendable. Emergency procedure. So drone comes with various emergency procedure. Return to launch, landing, or intentionally crash. You can crash the drone if you are thought it poses a danger to others. Training and skill level before flying the drone, or before flying the drone at high speeds, before flying the drone in a kind of restricted areas or in very narrow spaces. Be sure that your pilot is perfectly trained and can handle various environment changes. First, start with a valid area, having enough quite big area, and then move to the restricted area. Okay, and legal and ethical consideration. One of the legal aspect I have shown you the Indian aerospace map, and the ethical consideration is that do not fly some other private properties, and do not fly some institution which is having a red zone. And as per as the pre-flight checks, the drone should have a post-flight checks. Inspect the drone after return from the flight. Check with if the drone has damaged or is there any critical logs you want to analyze. Download the logs and analyze the logs for your better understanding regarding the drones. And again, some important points from the vision system. Vision system has a limited ability to sense and avoid obstacles and to perform may be affected by the surrounding environment. Make sure to maintain visual line of sight with the aircraft and pay attention to the prompt in iDrone map. As vision system of the drone is the same as the vision system of a human being, as you are not going to see direct sun because it sunlights affect our vision system. So same as the drone, when a vision system is getting interfered from some strong light source, so drone system vision system may misbehave. So use the vision system in adequate lighting, not excessive, not below the bar, just in a perfect lighting to rely on the vision system. There are some checkpoints that a user particular need to remember while working with the vision system. I'm going to read some for you. The vision system cannot work properly over the surface that do not have clear pattern variation. The vision system cannot work over flying over a monochrome surface, just black and white, or a perfect a single color. Flying over high reflective surfaces, mirror, water, or tiles, high over water or transparent surfaces, moving surface. Do not take off the drone from a moving surface like bus or a gypsy that carries payload or carries drone. Do always take off the drone from a stable platform. Flying in an area where the lightning changes vertically, like a flickering light or some other conditions. Over extremely dark, less than 10 lux, or over extremely bright, 40,000 lux. Strongly reflect or absorb like mirrors or absorb black body, and flying over surface without clear pattern or texture like tiles or mirror surfaces. Flying over surfaces with repeated identical pattern or textures like tiles of same designs, or the you are having a texture of the same design. So it is recommendable to have at least 3 color in your pattern beyond below your drones. And flying over obstacle with small surface areas, because drone obstacle system has a very kind of a body seal, very it can capture very light body. It can't capture actually very tiny bodies, so you have to fly it around the obstacles that have enough big body figure. Do not, and again, just ethical. Do not tamper with the sensors. If you think you have if the sensor misbehaves or you somehow mistakenly tampered with the sensors and other things, just report to us and we will look how we can resolve the issues. So these manuals are all of the manuals that illustrate the drone operation, safety procedures, and how to handle a drone in different environments. This is just a one manual, but there are some multiple manuals regarding the safety of users and as well as the safety of the drone. So this is the user manuals. This is a quite big manual, but it is mandatory to read all the manuals. And again, because it's all about your safety as well as the drone safety and the safety of your peoples nearby. The one thing that everyone wants to know how to control it with the joystick. So in the user manual, you can refer to the joystick section and it illustrates how the joystick pre-mapped buttons works on the joystick. It's a page number 27 in user manual 28. So there are if you have a joystick, you can have it in your hand, and there are particular modes that are already mapped with the joystick in the iDrone map. So this particular button supports zoom out and zoom in. The Superna drone doesn't support zoom out, zoom in. It only supports camera gimbal movement, since it's a very wide FOV, so it doesn't support zoom in and zoom out. This is a loiter mode. The loiter mode uses the vision system to maintain its position. This is a guided mode. Guided mode, the drone will take its decision by itself. These two modes are mapped to the joysticks. And then these are the two joysticks like yaw and throttle. This is the throttle sticks, which is actually going to be used to change the altitude of the drone. This is the yaw stick that is going to be used to yaw the drone to move it on its place, like rotation in z-axis. Then this is the second right sticks. So this is pitch. This front is the center sticks is going to move the drone forward and backward, and then this is the roll stick that is going to be used to make the drone roll left and right. Now camera controls. So this 4-button D-pad button, we called it D-pad. So this up is a camera up and this is a camera down. Supernova support these two buttons. Camera left and right is not supported in Supernova. Now land button, say this button is a X button, basically the left side of the secondary D-pad. So it is a land button. Now the downward button is a arm button. The top button is take off to 1 meter. In new hydronym software, in the updated hydronym software, this button has been removed and moved to the software and has been taken off to the 5 meter. Now this is a disarm button as we are talking about the failsafe feature land, return to launch, and the crashed button. So this is basically a crashed button. You have to pull this joystick down and press this button to immediately stop the drone and make it crash intentionally. And at the end of the manuals, there are some contact details that you can contact to us and report any error, report any feedback, or for any uh, technical support. So this contact us page is at the end of every manuals, and this is all about the kind of user manual. Then we have the flight manual. Basically, our flight manual is just listed. I'm going to, because it's a drone, it's going to be a very lengthy session, so we are just going to the content in which manuals you are going to find which content, and then we will going toward the practical demonstration of the drone flying and launching it over the 5G, controlling it via Wi-Fi as well as over the 5G. So this flight manual supports what is the flight modes, each flight mode. So like a loiter mode, what does it means by the loiter mode? What is mean by the guided mode? What is the mean by the auto mode, land mode? So these all buttons you are going to see on the iDronum software. So before accessing, before clicking any button, you need to what this particular button going to do. So these definitions are mentioned here and some kind of cautionary notes at the bottom of each mode if they have some. Then have the pre-flight checks, how to do pre-flight checks, how to do structural checks, how to flight area checks you are going to flight, and we have mentioned the DGC, digital skylink, directly into our manual. So this is basically a reference to the external website. Now the GCS software, C2 links and control checks, 5G mode, Wi-Fi mode, hotspot mode, pre-arm modes, GPS outdoor, compass check, proximity check, GCS check, battery check, visual odometry check, safety switch check, takeoff and general flight precautions. When you are ready with the flights, every check has been passed, now you are going to flight the drone, then these points are illustrated your flight precautions. Then fail safe configuration, how to configure a particular failsafe, battery failsafe. If the battery below falls 11.5, the mid drone will go to into land mode and will go to the descent mode. Failsafe is FS is just nothing but a failsafe. C2 is a command and control link, and the GCS is unable to communicate with it. Will take wait for the 3 seconds and then do the failsafe check and get into the failsafe mode. For the outdoor, what modes you are going to configure? For the outdoor battery failsafe, it need to be RTL mode. For the GCS failsafe, it need to be the RTL mode. For the indoor, okay, so for the indoor mode, so battery failsafe, it need to be land. For the GCS failsafe, it again need to be land. For the outdoor, it has been mentioned here. Then in case the crash happens, so this is the post crash investigation. So you will see the, and now this is the software installation. We will going to see the software installation in the practical manner. So the software, in case you are going to further install the software, so these are the software installation guide. But so this is all about the manuals, and there are some other manuals, like if you are going to deep dive into the UAV system architecture. We will discuss the UAV system architecture after the flight, and then we have the processing specs. Now the command and control manual. So this command and control manual illustrate how you can configure the multiple modes of the drone, like into put into the 5G mode or into the Wi-Fi mode, 5G mode, hotspot mode, Wi-Fi mode, network mode, switch, web page, contact us. So connection modes, what type of connection we are going to use here. Your serial number is Suparna 5G with the drone that we have in the lab is 5G081. So this is your serial number over the Wi-Fi, and you can connect to your drone like this over the Wi-Fi. You can switch connection from Wi-Fi to hotspot mode, and network mode switch. And network mode switch go to the Wi-Fi 2.5 or 5 gigahertz. So this everything has been illustrated and well mentioned into the manual. Every detailed step that can you can access the drone resources on your private 5G, on your private Wi-Fi network, or you want to use the drone existing interface. Then we have battery charger. So battery charger is how you're going to charge the deplete battery. Do not deplete the battery with less than 11.5. Charge it quickly. And battery chargers, we are initially providing 3 chargers: SkyRC PD60 and Idronum Wi-Fi charger are on charger. So the detail mentioned to connect with the settings that are going to be used with the battery you are having with the Superna drone. So what are the parameters you need to configure? So if you have an SkyRC, you will receive an battery hub and it is connected to the charger. These are the settings what you are going to feed into the charger to make it charge the battery. Then we have the PD 3.0 chargers. Then this PD60 charger is working on a power delivery 3.0 protocols, and can be used by PD Type C to Type C. So if you receive this charger, then you can follow these procedure. And at the end, if you received the Sperna charger, autonomous Wi-Fi charger. So you just need to connect the battery. It's a smart charger. It will manage all the parameter by itself. You have to connect to the app, whether it's a autonomous app or your the Android app that you have received. So just press the start charging button and the battery will start charging. And this is all about the Sperna charger. This is easy to handle and to charge the battery. It has a automatic some fail-safe feature that will cut off the battery in particular. These are the LEDs indicators for these Sperna chargers. You can have these manuals to charge the battery. If there's some modification at your end, you want to have a specific information need to into manual, feel free to contact us and we will modify the manuals. Then we have the processing specification manuals. So this processing specification manuals is just the onboard flight controller that we have inside the drone. What are the specific process specification for this? So the, the SoC that we have used is Broadcom BCM2711, has a 4-core CPU that has a 1.5 gigahertz speed for each core, and it has a 4 GB of RAM and 32 GB internal storage. Around 10 GB is used by the drone internals, and the remains 25 to 26 GB are available for the end user. Onboard capabilities are all the capabilities that Supama supports. So this is the processing specs manual for to plan your use case accordingly. Depends on these use cases. These specifications. So this is all about the manuals. I think we have read all the manuals. Then the training document is a document that we have provided and get the summary that we are going to demonstrate today into the training document. UAV system architecture. This is a document we are going to illustrate, or we are going to read it after the flight, after the practical demonstration. So you better understand how everything works and interconnected inside the drone. So now how to get started with the drone. So we are going to the idronum.com. software, and first we will install the software. So we will get started. So the 100 5G labs comes with the enterprise version. So you have to continue with the enterprise and enter your organization email. It doesn't support Gmails, Outlooks, XYZ, Biz. You need to be your organization email to get verified. And then it's a OTP based registration. So if your organization is not registered, you can go to your mail, copy your OTP, and enter the OTP and verify. If your organization is not registered with us, then you are going to redirected with the registration page. If your organization is, if you are a user, if you are a user of, or if your organization is verified but user is not registered, then you are going to redirected on a registration page. So since registration is specific to the organization, you have to provide your all details. So I'm skipping the organization registration. And after the successful registration of user and organization, you have to see this dashboard. So first you have to go to the buy plans, and in the buy plans you have to activate a 5G lab plan for your lab. Once your plan is activated, it will comes under the tab of active plans, and now you are able to generate the tokens. Then the tokens are the unique identifier for us to identify your lab. So you can generate 4 tokens for your lab, which means you can add 4 devices for your lab. And how to generate tokens? You have to just go to the generate app tokens, select your 5G lab plan and generate the token. And a token will generate it for you. You can copy it from here, or you can get to the app token. All the app token will go here. So this is a very lengthy string. Do not try to write it by your own, just better to copy or paste. So this is the encrypted strings, which is only identified by the acronym, and there is no sense to make it write down. You have to just refresh the page, go to the app token, and your token is available here. The token that you have used with your devices will be here, and your username will appear here, like Anupilawat PC. So you can copy here, or Anupilawat PC will now only appear for the Anupilawat PC and not for the other system. After you have successfully, first I'm summarizing what we have illustrated. You have to buy the plan. I have already existing the subscription. Then you have to generate the tokens. Then you have to go to the install Hydronom. For the Windows purpose, you have to download the Windows version. It will start downloading like this. After the downloading, you have to install this setup. It will ask for some permission. Agree to all of them. And just I have already installed the Hydronom, so I'm cancelling it. And for the Linux, initially, if you are a first flyer and never been with a drone ever before, so please start with the Windows applications. And once you are a frequent flyer or a trained pilot, then for the development purpose, switch to the Linux. Once you have installed the Hydronom for Windows, so you can go to the your Windows Hydronom Enterprise and open the application. This application is basically for your captive 5G network, and this it works for your internal institute. You are not going to able connect your drone outside of your organization. So this implements all the private 5G networks to connect your drone. If you are going to fly with the public 5G, so you have to use the iDroneum cloud, and it's not going to be used with private 5G network. For the 100 5G lab, you are not able to connect it with the cloud, but only for the private purpose within your lab. So we are going to use iDroneum for enterprise app. You can create a profile or you can delete a profile. So I will delete a profile here, and also before proceeding further, the token that we have copied from here, it's need to be entered in the iDroneum app here. Since if you are not a registered user, you will have a prompt of enter the token here. So you have to enter the token there, and after that you are able to see this screen who is flying. You can create as many as profile you want. There is no restriction on the profile. So for the to do demo, I will create a 5G demo lab. Lab. I am 5G lab. You can add the profile. Profile is okay. You can go to the profile and you accept the term and condition. It is always better to read all these term and condition before flying the drone, and agree and continue to fly. If you press this button, that means that you are agree to this user declaration. Then you have comes with this dashboard. So this is the dashboard, and in the dashboard we have connect your go to your vehicles. I have no vehicle added since I have created this profile very new, and you can add your vehicle. You can share your feedback to the developers. You have no vehicles. We have never fly the plane with this profile, so blank flight history. We have zero saved videos. You can access the charger apps. If I am in a proximity of the charger, so this app will give a prompt that you are very charger and want to connect with it. So you can connect to the charger and start charging your battery if you have the iDroneM charger. Then you can download maps for your offline purposes since the downloading the maps require internet. So you can at your premises first download the map, and you can go to the fly the drone. So initially what we suppose three kind of map, which is a open street map, which is open street map for the open map. This is a Then we have the iDroneM map. iDroneM map is only available in Chandigarh, Punjab University, and not in India. And then we have the OSM cycle map for a detailed map up to the zoom level of 21. So I'm having issue right now with the internet. So wait on it. So you can download a particular section to fly with the offline. So if you are not connected to the drone, connected to the internet, you are still able to get the maps and the drone location on the map. This is a ticket tour. If you are if you are not familiar with the iDroneM, you can take a tour, and this things will state what a particular thing is, and you can take a tour at any time. Now, to set up the drone, I will first connect it to the Wi-Fi, and then we'll transfer our control to the Karthik so that we are able to control the drone over the 5G to find the IP, connect to the drone, and to make it fly. Right now, for the demonstration, since I have to connect with the internet, so I'm going to connect with the drone over the Wi-Fi. Since I'm not connecting to the core directly, I'm not on a private 5G network, so I'm going to use it over the Wi-Fi. For the Wi-Fi, the iDroneM comes with a default IP, and I will name it Wi-Fi. Drone legacy support, and you can add vehicle. Once the vehicle is added, it has been into the all vehicle. So Suparna 5G Wi-Fi. Once, so for the indoor, you will see a tour like what a particular thing is what. So this is the data panel where all the drone telemetry is coming from. Then the individual icon. So this is the drone current mode. This is the indicator that the drone is ready to fly. Since it is a cross, drone is not ready to fly. We are failing some pre-flight checks. Drone altitude right now, since it's a barometric altitude, it can fluctuate, but once the drone in the height, it will use the centimeter level precision of the rangefinder. These are the airspeed, battery voltage, satellite. So right now we are not into the satellite coverage. So if we are going to fly the drone, it's a GPS denied environment. These are the GPS and compass status. These are the drone HUD level. These are the arm mode. This is the loiter mode. This is the land mode. This is the more option button. And then this is the drone reboot button, then the calibrate level. If you think that over the course of time the drone level has been altered, so you can keep the drone at a leveled surface and press the calibrate level button. Safety on or off switch. Flight modes. Since we have no flight modes right now, additional flight modes, so all the flight modes you are going to see in the bottom of your screen. Environment, you can switch the environment, like environment toggle, outdoor or indoor. If you are not, environment change is not available while in the flying. Compass, calibrate compass or cancel compass. This is an outdoor task. If you are going to fly the outdoor, you need to calibrate the compass. And just press the calibrate compass button and make the infinity sign in the air with the compass in all the direction. Fencing, so these are the fencing disable. So for indoor we have disabled the fencing. So fence breach altitude, these are the parameters for fencing. Then we have the avoidance. Right now the avoidance is on for the indoor. Fail safe, ground station fail safe, low battery fail safe, return to launch fail safe, critical battery, and some hints and tips. Now this is the joystick and this is the video stream container that will show how the drone video stream coming, and once the tour is completed you are calibrating. So the buttons is also mapped into these parameters. So if you are flying outdoors, so right now let's discuss in detail regarding the fencing. So fencing means that you have a geo points that you want to drone never cross that area. We will create a geo fence. So in this demo itself, after a while, so what the geo fence do? You have to kind of draw a geo fence. You have to draw a geo fence and enable the geo fence. Then you have to show what action need to be taken when the geo fence is breached. You have to reports only. If you set it to reports only, then the drone will make a notification fence breach, fence breach, fence breach after interval of 5 seconds. If you make it a RTL or land, then drone will report fence breach once and then trigger its mode to the return to launch or land. Fence breach altitude, so the height. If I'm setting it 15 meter, this means that drone will never go beyond 15 meter. And avoidance is just nothing but on or off to avoid the obstacles. Compass, environment, flight mode, and we have fail safes. So fail safe, as we have discussed earlier, what kind of fail safe? There are ground station fail safes, battery fail safes, and the RTL fail safe. So ground station fail safe is when what drone will do when a communication to the ground will lose. When the communication to this system lost. So right now it is a land. This means that in the indoor mode, you have to take this land. So drone will land when we lose the communication. Low battery, it need to be land for the indoor modes and the RTL for the outdoor modes. So for the indoor modes, we have to make it RTL. RTL failsafe altitude, since you can fly the drone at a minimum height of 5 meters. So RTL failsafe altitude is that when the drone is in RTL failsafe mode, at what height it need to climb to clear the obstacles nearby. So right now, if I'm flying the drone at 5 meter and the any failsafe occur and it was in a RTL mode, so drone will first make it move to the 12 meter and then make a direction to the launch point. So right now in the land mode, this value is inefficient. You can skip this value in the land mode, but need to set when the failsafe are enabled. So this is a drone will look like, and the map that you are going to lab. This is a pretty big lab. You can see in the camera. This is I am here sitting here, and Karthik with the 5G rack is sitting here. So this is a pretty big lab, and these yellow lines are showing the obstacle. Since no obstacle is in the red form, so once the person is nearby the drone, it will turn red. Okay, so we are moving to the front of the drone, and it will trigger red, 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 red. So this indicates that the obstacle avoidance is on and the obstacle is working fine. Yellow means the area is enough clear to fly the drone. And this is the 3D map that the drone is placed. This is, you will see the actual drone flying here. And right now we are not in a state of drone is not ready to fly. So what message hardware safety switch? The drone is asking for us to have a hardware safety switch to make it ready for the flight. We go to the more option. In the general, we have the safety virtual safety switch. When you trigger it off, drone will switch to the ready to fly. Now drone is ready to fly. So I'm triggering it off. And this is all about how to install the software, how to get ready with the drone software, how to get ready with the connectivity. I'm discussing with the 5G Wi-Fi connectivity, and in a quite later, the Karthik will discuss the 5G connectivity. So we have inserted a SIM. We have inserted a SIM at the back of the drone, just for the reference. At the back of the drone, there is a SIM card slot at here, so you can insert the SIM card. We have already inserted the SIM card and drone is powered on. So regarding the Wi-Fi, this is all about the drone connectivity, drone software setting for both. I don't know how to verify your organization, how to install this software, how to connect drone. And once the drone is connected, so you can see the video here. So this is the saved video. You can download this video for your further processing if you want to, or you can just escape it. If you want to delete the video, there is a close button. If you want to play the video, there is a play button. And if you want to download the video, open the video and go to the three dots and you will download the video. So this is regarding the software setup, Wi-Fi connectivity, adding your vehicle. Since when we are going to the 5G network, so this IPs will change and will be allotted in the 5G series of the SIM card. So we will demonstrate it. So for the practical, now we are moving toward the practical demonstration of the drone. So what we are going to demonstrate, we will first flash the drone over the 5G, get it IP inserted into the software for the private connection, and then we will fly the drone inside the lab. We will move the camera up and down, and then we will perform the obstacle avoidance. I have discussed all the parameters that you need to set up in an indoor environment. And if you, I will summarize the parameter. For indoor parameter, go to the more option. For indoor, environment need to be indoor, fencing need to be disabled, avoidance need to be on, and fail-safe need to be on land. So these parameters need to be configured before flying the drone indoor. So if you, and then after once every pre-flight checks is completed, you are left with the safety switch. If I turn this on, you will see the green tick. If I'm turn it off, you will see a red tick, red cross. So this means drone is not ready to fly. You will do anything with the drone, but it will not ready to fly. So now I will request Sonu sir, please provide the presentation right to the Karthik Pathak.
Yeah, sure. Shoaib, Shoaib,
Hello. Yes, yes. Hello.
yeah, please make a presenter Karthik Pathak.
Karthik. Okay, okay. Karthik. Yes, given. Right given to Karthik Pathak.
Thank you.
Welcome.
So screen is the screen visible, Sonu sir?
Yes, 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 Karthik.
Okay, okay, sir. So Karthik is presenting the screen and I will narrate what we are going to do with the drone. So right now we are going to the core logs. So you have the UI, GUI we will provided by the VVDN to get the IP of the drone. So right now we are into the core logs and will identify the drone by its. So drone is located with 10.450.6. So we will add this IP into the as a vehicle and then connect it to the vehicle. So right now the screen you are visiting right now, it's totally over the 5G. The radio we have in the lab, the drone we are connected with is into the 5G mode. So we have turned off the safety of the drone and now drone is now able to fly. So Karthik is arming the drone and then in the video you will able to see the drone is flying and it's altitude is around 1 meter. So we will maximize the videos. So I'm here moving my hand. So this is our cycle lab and the drone is flying at altitude of 1.3 meters. It gets hovering at a stable height. So right now I will perform the obstacle avoidance dance. I will mute my mic and will demonstrate the obstacle avoidance to you. So when I approach the drone from the front, the drone is keeping a safe distance from me and moving towards the backward. And you can see on the line that move backward. And after from the front, I have moved to the backward, and drone will start moving towards the front to keep a safe distance. And again, this is a safety feature. Obstacle avoidance is only a safety feature, and you are not doing in a very restricted space. Have enough clear space so that drone can move here and there. And after the successful flight, you can press the land button so that the drone will automatically land it to the zero height. And this is the 3D map that we have from for our lab. And it has a very kind of equipment placed around here and there, like we have a table at the backside and the chairs at the very low level. And so this demonstration is totally over the 5G N78 band and controlled by the Karthik over the joystick. So if you have a 5G expanded over the floor, then you are able to control the drone over the SIM card by sitting inside the lab. And this is what we call the internet control drones. So you can able to fly from anywhere. And then we have the public. Okay, so voice is not clear. Actually, sir, we are flying the drone at the back, so the noise is getting into my voice. So this is all about the practical demonstration of the drone over the 5G, and just keep the parameters in mind. So your drone at the lab will also behave the same. We are still getting the zero satellites here. We are having on the first floor in a fourth floor building, so it's be very rare chance to get a satellite here. So what right now we have performed is a GPS denied environment, totally using our vision system, both forward and downward. So I will. This is done from the Karthik side. Sonu sir, can you please make the presentation right to the Anup Elawat?
Sure. Shoaib, please make Anup Elamat once again.
Okay, 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 okay. Yes, given, please check. No Pahlawat.
Yes, sir. So since we have flight the drone and we have now aware of the various term like vision systems, rangefinders, depth estimators, drone flights, companion computer, flight computer. So now we are going to discuss it in detail how they are interconnected inside the drone. So you can have, if you are planning to have your use case, whether we are going to fit on this particular drone or not. We have discussed the processing specs of the onboard computer a while ago, and right now we are going to discuss the detailed architecture. So Suparna detailed architecture. So actually right now first I will demonstrate this one, and in case this one. So this is the first diagram that how everything inside the drone is connected. So we have a flight controller which is dedicated for the flight only, and then we have a mission computer which is a powerful computer like 4 core 1.5 gigahertz 4 GB of RAM, so that we can perform a very critical task there. Flight controller is only getting the data from the sensor and make the drone stable in the flight, not moving it here and there. Mission computer is the computer that is actually calculating the bulky data from the sensors and providing vision position estimates to the flight controller. So we are using a Mavlink protocol to communicate between each other. Then flight controller having a control of motors and getting a data from IMU, barometer, GPS, and downward facing flow system. They are connected to various I2C, CAN, and SPI. So like barometer is connected over the I2C, IMU is connected over the SPI, GPS is connected over the UART, and flow is connected directly via Mavlink. Then this mission computer is connected with the flight controller via Mavlink packet, Mavlink protocol. And mission computer is actually the where the vision system is calculating its estimates. So vision system is basically getting the data and feeding to the mission computer. Then vision computer is extracting the position of the drone in the GPS denied environment, and then its position references will be passed to the flight controller to maintain a particular position. Then this mission computer is able to communicate with the interfacing. Right now, radio means the 5G and the Wi-Fi. Here are the two interfaces: 5G, Wi-Fi, and the 5G. Then this mission computer is using the Linux. Then all the OS that is running in the mission computer is OS, and the algorithm that we have separated is are using collision avoidance, collision prevention, safe landing, visual inertial odometry. Then the middleware is actually the RTSP. This is a misprint. This is a RTSP, Mavlink, and the routing. So we are getting the camera feed. So this camera feed actually. I'm opening the advanced software. So this data is coming from the flight controller. This data is coming via RTSP by the companion computer, and then this 3D map is formed. This map is formed by the companion computer. So these are the data layers that we have used inside the drones, and then the middlewares are to communicate with each other. Now regarding the flight controllers, this flight controller, that combined module, is now called as a flight controller, and we have the 5G modem that has been taken out the Mavlink packets and via the 5G modem and then transmitting it over the 5G network, and then same it is doing the same via the Wi-Fi interface as well. And there are the multiple apps and modules that running to make it feasible inside the drones, and this is just a normal sensor connection. This is just a normal sensor connection. So these are the companion computer, what we have defined a companion computer and its block diagram. Data and control flow architecture, how the data is flowing in your 5G lab. Like this is, you can imagine the drone is here, and then we are communicating via the 5G, and then this data is transmitting to your all the layers, so you are accessing it from the laptop, from some other point of communication. Then we have the how the collision avoidance and how the UAV controlled algorithm is basically detecting the collision avoidance. If actually collision avoidance is done by the multiple sensors, It is done by the depth estimation as well as the vision system. So we take the input and then the sub window calculates the depth on the each frame that we are getting, and then the average depth is calculated to reduce the noises, and then that message is packed into the mapping and sent to the flight controller for the collision detection, and then collision detection is ultimately leads to the collision avoidance. And then the commands being generated by the motors so that they don't move in a particular direction. So these are all the definition regarding the same, and then the protocol overview. So okay, we have left one thing that is basically a plannings, path creation. So for the path creation is only available in outdoor mode. So we have to go to the more option, change the environment to the outdoor. And we have to complete the outdoor tour. Again, most of the things are same, but some modes has been added. So some modes has been added like guided and auto. And RT, since we don't have an GPS position and we have switched into the outdoor environment, so the drone is considering it as a glitch. So this is the right now we don't have a GPS, so it's a 00 position on the global map. So you can click the right. First, we will create a fence. So you have to right click on the map anywhere and go to the option create fence. Then you have to click 4 points or multiple points, 4, 5. So this is the fence. Now drone will never reach this boundary and we can upload this fence. Fence has been uploaded, then you can right click on the map and click to read fence. Then you are getting this fence. So this fence is only useful when you have enabled the fencing. Right now I'm disabled the fence, so this violet circle is of no use. Violet polygon is of no use, so we have to enable the fence to make use of this. Now when I enable the fence, then drone will never reach this boundary. And if drone reach this boundary, then it will trigger into the fence section mode. So fence section mode is right now click on the RTL, which is nothing but return to launch. So if the drone breach this boundary, it will trigger a return to launch sequence and drone will get back to the position from where it can take off. The pilot can change the mode in the violet polygon anytime, but will not be able to switch the mode once the drone is outside the polygon. Now we can create a flight plan. You can create a flight plan like 0. I want to take a drone from the 0, then move to the 1, 2, 3, 4, 5, 6, 7, 8. You can add as many as point. And then at the 15 point, I want to make the drone return to home. And you can upload this plan. So this plan now indicate like team is take off, drone will take off from this point and follow this path. And then at the 15 point, it will launch a return to launch sequence and drone will return from where it has been taken off, which is basically at this point. So this is regarding the flight path, and you can set the altitude also. You can create the flight plan and you can create the altitude. Right, by default it's a 30 meter. You can create it to the 10 meter. Never fly the drone below 5 meter because of the interference by the earth magnetic field or nearby structure. Always fly the drone above the 5 meter. So this is you can get the height and anything you want to, but have a very flying limits like 30 meters. And you can when upload a plan, so the points will be on a 30 meter. You can manually change the height. Like at the first point, I want to change it 30 meter. Then for the first point, I want to make it 40 meter. And then for the third point, I want to make it 50 meter. And then for the third point, I want to make it 20 meter. And then for the fourth point, I want to make it 10 meter and the fourth point is need to be written to. And then you can upload the plan with this variable height. Right now we have this plan, so just clean it up. You can press the return to launch. So the drone from anywhere the drone is, it will go into the return to launch sequence, and drone will try to return at the position from where it has been taken off. If you trigger it to land mode, so drone will try to land from where you have triggered the land mode. Auto mode is required to follow this grid. When you have uploaded the grid, take off the drone successfully to the height of 5 to 10 meter and then trigger to the auto mode. To make the drone fly from here and there without creating a plan, you can make the drone into the guided mode and then right click and make it fly to here. When you are in a fly to here mode, drone will ask at what altitude I am going to fly at this point. You can set any altitude using the multiple. We can support manually by 105 meter, and you can have this altitude by you can get 20 meter and set this altitude. Then drone will now move here if it is in a flying direction. So this is all about the drone. So summarizing the same things, we have discussed how to install the software, how to configure the drone indoor parameters, and how the drone is going to take off. So takeoff is basically just arm the drone with a button. It's written in the manual since we are not have a camera to demonstrate you, but it's written in the manual and it's been in the video itself. So you can follow the tutorials to take off the drone. But first and again, read the manuals. Everything is mentioned there. What parameter need to configure for indoor and what parameter need to configure outdoor. Indoor parameters, since we are assuming that it's a private 5G lab, so you are going to start with the indoor. So we have discussed and set the parameters for the indoor in very detail. So is there any doubt? If there is still any doubt at any point of time during the flight of the drone, feel free to contact us. Just do not kind of a lack of do not have any lack of awareness regarding a particular point, because we understand that drone flying is a critical task and you need to be, and most of the terms is very new to the most of the people, and it's very hard to grab it in a one time, but we have mentioned them in the manuals, and again read the manuals and fly the drone for yours to have your own safety as well as of the others. So Sonu sir, this is all from our side. If anybody has any question, any suggestion, and want to ask something, feel free to use public chat.
Yeah. Hi, team. If you have any doubt regarding the drone, you can ask. You can chat also.
Hello, Anup ji.
Yes, ma'am.
Yeah, I'm from COEP Technological University, Pune. And as you mentioned, the red zone part. So our college comes in that. So during the UAT training, etc., we have done it momentarily in the backyard and all those things. But later on, if though it is a research drone and I have to carry out some activity based on this, how I should be going, means should I have to take some additional permissions, etc., because I know our college comes in the red zone, and considering the 5G lab distance, it will be like limited connectivity. So how we should go for it, or what additional permissions are to be taken?
Okay, ma'am. So actually, there are two kind of red zone because every government institution is in a red zone. So you have to please verify at your end that it is a red zone of your institution or it is a airport red zone or nearby any airport or nearby to any army area cantonment. So we are requesting you to first judge that what kind of red zone it is. If it is a red zone of your college, then you have to need a permission from a local police station and your college as well to fly the drone outdoor under the research project as up to the height of 20 to 30 meter. But if it is in a red zone of some government authority, so you need a flight permission as per the DGCA guidelines. So DGCA guidelines, there is a document on the Digital Sky platform that illustrate how you can proceed with the flying clearance for your research project if it is a very near to government authority buildings.
Okay. Okay. So, like, I
So,
have to first verify which is the red zone, and accordingly, I
yes,
should
ma'am.
decide plan of
Yeah,
action.
yeah. So for this purpose, what I am saying right now, so you can go to the Digital Sky and there is a DTU, Delhi Technical University. So this is
Hmm.
actually when we are trying to demonstrate it over DTU. So it was on a red zone, but now red zone is removed and it's moving into the green zone. So green zone has no restriction for having a research project up to the 20 to 30 meters. But if you are flying commercial drone, then it mandatory require permissions. So like in the DTO at that time, we have asked the highest authority to provide a clearance to fly the drone at 10 meter to escalate the UAT. So at that time, we have grabbed the permission at that time because generally it is in a green zone, but for a momentarily, it was in a red zone.
Oh,
So,
so
Anup, can you
by
check
the,
that COP currently is
yeah,
in red zone? Can you check that? COP
I was
Pune.
about to ask the
Actually,
same.
I don't have the
Can,
location right now because
no, no. Can you
I
type that COEP?
COEP.
Yeah, Pune.
College of Engineering, Pune.
Yes,
Shivaji.
yes,
Hmm.
yes.
So it is in a red zone,
Hmm.
and there are the multiple
So,
red zone actually.
yeah,
So maybe
I
nearby there is
mean,
an army
during
cantonment.
training only, I came to know okay, it is a big issue. So we have done it only momentarily. Sonu Singh only carried out the trials and all. But like
Yeah,
I was thinking, the trial is fine. But later on, if our students are interested, so I have to look for.
yes, ma'am. So actually I can't comment from here because actually generally airport look like this.
Hmm.
A red zone, then a yellow zone, then followed by the second outer yellow zone, and then moving into the green zone. So this is the
Hmm.
basic pattern for the commercial airport. But since your college is somehow not, you have a airport nearby, but then there are the some scare patterns as well, indicating that this is some government
Yeah, some
institutions may be very
government
nearby.
offices are also nearby in
Yeah,
Shivaji
so
Nagar.
these are the, yeah, there are very far small circles indicating a individual institution. So you have to check your local rules regulation.
Okay.
You are in a yellow zone generally outside the
Hmm.
airport, but there are some red zones available for the
Small circles.
institutes, not for the airports, but for the institutes. So you can check your local rules and regulations. Generally, a police station,
Okay.
they
Okay.
can
Thank you.
assign a temporary, they can assign you a temporary flying license up to the 20 or 30 meters. So you can
Hmm.
operate within your private premises.
Okay.
Okay, I'm Seato. And now Ayushman Singh, IIT Gandhinagar. What is the range of this drone? Suppose we are sitting in 11 drone is flying in outdoor zone. And will it be giving if I cross the range, assuming fence is not enabled? No, actually, the drone is not going to give you any warning when you are in a fail-safe mode, but you are experiencing a drop in data rates. Like you are going to receive a packet in a kind of a buffer manner, like a buffer not in a continuous state. So drone has an internal check for the packet loss, but from the radio to the drone, we don't have any kind of algorithm that can judge the radio strength to notify the user. But when you are in a private 5G lab, I think you can, if you are you are into the developer mode, you can check the power that is a particular module is getting, and if it is increasing or getting interference from the other, you are kind of notified that the drone is far from the range. Drone will wait for the for your kind information. Drone will wait for the 3 seconds before disconnecting or before going into the failsafe sequence. Drone will wait for the 3 seconds in case it is received any message. So if the buffer that you are receiving in a very little manner going to be received within a 3 second, then drone will not fail safe. But if it is not receiving in a 3 second, then drone will go into the fail safe mode. And I don't think you can use your radio and 78 band radio outside because it is a private license and you have to keep your radio radiating within a private zones. Uh, any other doubt? Any other question regarding the drone? Okay, Sonu sir, I think there are no doubt. So our part is over. I would like you to take over.
Yeah, thanks, Anup. Wait for next few minutes. Hello, hello, Anup.
Yes, sir.
Yeah, wait for 5 to 6 minutes
Okay, sir.
for query. Yeah, it may be
Okay,
come.
sir. No problem, sir. We are waiting.
Uh, Vinod sir, Vinod sir. Okay. You can also write in chat box your query as well. We will respond on that. If someone wants to chat, then you can. Anyone from SIT, Symbiosis Institute of Technology, Prabhat ji? Prabhat sir? Anyone from SVNIT? Yeah, okay. It seems that there is no query regarding the drone. Thank you, Anup, for your
Okay. Thank you,
support
everyone.
and
Okay, sir.
explanation the drone and training.
Okay, sir. Thank you, sir. Thank you, everyone.
Thank you. Now for the today the last item. Are you? As I told initially that we are providing orange solution. So in orange solution, the RAN is split in two parts. One is RU parts and second one CUDU part. So today we will cover the RU is smallest, and tomorrow we will cover in the morning CUDU separately. So for RU, I would like to invite Mr. Vishnu Gupta. He will tell you about the RU and some basic commands by which you can get the information from the radio. And if you want to check the configuration point of view, he will tell you one by one about the connectivity and the key features and specification of the radio. He will cover and about the some RU unit, some specific environment specification, antenna specification, power connectivity, and radio specifications. And he will cover the about the LED indication, which LED, what is the mean of that. If suppose that only one LED is growing, so what is the mean and how you can rectify that one. These points basically we will cover in the RU sections. So I would like to invite Vishnu Gupta. So Shoaib, can you
Yes. Uh,
can you make a as a presenter, Mr. Vishnu Gupta?
yes, yes, yes. Wait, please wait a minute. Yes, given right to him.
Yeah, good evening, everyone. This is Vishnu Gupta from VVDN team. Shoaib, thanks for giving me the sharing the screen. I'm audible.
Yes, you are audible.
So, as you know, in a 5G deployment, we have given multiple things in architecture like a radio unit, CUDU core, and this MEC server. So now today I'm going to explain this RU unit, radio unit. So I'm going to so is it my screen is visible?
Yes, yes, your screen is visible.
For 25 institute, we have given this LPRU, low power radio unit, to all the institute as a radio unit. So this radio devices work on the 7.2 split of Orient technology. Basically, 7.2 split says the radio having the capability of this low-fi and RF unit. So in the hi-fi properties is inside the DU, in our radio having the lo-fi properties and the radio properties, RF properties are there. So as you know that radio which we are providing to us, like it's having the 4 cross 4 4 TX and RX antennas are there. So basically this radio is came up with the two options, like you can connect with the external antenna and as well as in the internal antenna. So currently the unit which is provided to all the institutes, it's having the external antenna only. As you see that black antenna are connected with this RU. So moving forward, the key feature of this RU, it is a node type deployment and it's having the one carrier component which support 100 megahertz bandwidth with 444R antenna. Its operating bandwidth is IBW is at 200 megahertz, means its PA range up to the 200 megahertz. Up to this, within 200 megahertz, we can configure 100 megahertz within this. Like yes, like just the radio which we have given, it is supported 3.6 to 3.8 gigahertz, and the configuration what we did in the college side, it is at 3.6 to 3.7 gigahertz we had configured in the radio, and currently the radio is supporting the single numerology. Subcarrier spacing is 30 kilohertz. As you know that 5G is supporting multiple numerologies. So currently we are giving the feature of this 30 kilohertz. An antenna which is provided inside with this unit is a semi-directional external antenna, and the interface with for the connectivity with the DU, we are providing this 10G SFP optical fiber port, and this radio unit is get powered up by the PoE with a 12 volt 5 ampere DC adapter, and the per channel output is a 2.5 milliwatt per channel. So complete 1 watt power overall he is radiating from the antenna side, and this radio is based on the 7.2 split technology. Moving forward to the specification side, like it support bandwidth of 100 megahertz duplex mode. It is working on the TDD duplex modulation. It can support 256, 64, 16, and QPSK, all of them. And carrier component, as I say earlier, it is support 1cc, means single carrier at a time, means all 4 channel we can transmit the single carrier only. Or per channel output is at 24 dBm, means 250 milliwatt per channel. And the antenna which is provided with this device, it is a semi-directional, and it's having to its range somewhere around 6 to 9 dBi gain. It is producing this antenna, and MIMO, the radio is supported by 4x4. So moving forward, if you see the radio, there are the 3 LED indications. So as you see, there are the 3 LED indications are displaying over the uh, front top. So this one is a power LED, this is the network LED, and this is the status LED. So as you know, as per the blinking of the light colors, you can identify what is running behind this radio. So first of all, this power LED. If if all the LEDs are green, that means our radio everything is working fine. As you know, when we are doing the UAT and training, you see we always instruct when when the status LED get green, then you have to push the active.sh file, just because that is indicating that our radio is get synchronized with the DU with a PTT clock, so it will get a stable green indication. So if power LED is blinking slow, it means that our radio is temperature is getting high, means it is a one kind of the temperature warning you can identify visually by seeing the LED indication. If it is blinking fast, it means some if you are doing the factory reset, so at that time that power LED indication will be blinking very fast. And if it is a red, it means some fault will be there. Either radio is not properly booted or some fault will be there, so it will be indicating as a red. If software upgrade process will be there, right now we have at the boot time we have showcased that green LED, but in future if any software upgrade will happen, so at the time of the software upgrade, that power LED will blink slowly. And moving forward to the other 2 LED indications, there's a uh, there's a network LED red indication. If it is slow, it means DSCP IP is not getting get to the radio via the DU. If it is fast, it means it is a factory reset mode. If it is stable, it means your fiber link is down. And green part, if it is slow, it is a software upgrade process. Fast means uplink trying DSCP, means your device is connected with the optical fiber, but he is looking for the DSCP connection. And if it is a stable green, means your device optical connection is properly connected and your device got the proper DSCP IP allocation. And it's have a blue LED as well. If it is a stable, it means some power failure will happen to this device. During the power on, initially it will glow as a blue. And some thermal issue will happen, then also this network LED get stable blue indication also. And same for the status LED. If it is slow blinking red, it means synchronization is failed. If it is fast, it is in factory reset mode. If it is stable red, some software upgrade failure is happened. And for the green line indication, slow means software upgrade in process. And if green is blinking fast, it means reserved for the future. Sorry that fast indication is not applied in this status LED. And if it is stable, it means our RU is logged with the synchronized and PTP is connected. And blue is stable, it means some thermal issue will be there in a RU. So now moving forward, like how we can connect with the RU and going to the RU console. So first of all, to get access in the RU, first of all we need to uh, get the SSH connection toward the CODU. From CODU, we can take SSH by using the IP 192.168.4.50. As you see, like after getting into the CUDU, we do the SSH login to the RU by using this command SSH root @ 192.168.4.50. And then after it will ask for the password we will place that VVDN. So this kind of screenshot we have placed, this kind of the screen has came. Now we'll demonstrate like how to do login in a RU.
Hello.
Yes.
Actually, hi everyone. One meeting is going to start for mentorship program. Welcome mentorship program. So, for VVDN also, you all can join the link. I am sharing the link. Okay. So everyone can join. Hello, Sonu bhai.
Haji, Haji, yes.
As per the Subham sir, you all have to join the link.
Yes, but we will take next 10 or 12 minutes only. As per the
Okay,
schedule only, I
then
will told.
everyone can join the same link. 6 बजे तक. Only 6 at 6 p.m. That will be in 5 to 6.
5 to 6.
5.
Yeah, before the 5 we will complete.
Okay.
Okay,
As
okay,
Okay.
already we share the schedule. This is very smallest we keep in the last.
okay,
That's why.
okay, sir. Thank you.
Because it is also the same necessary
Yeah, yeah, yeah.
to use the RU configuration and all that. That's why.
Okay, please bind it at
Sure.
5. Yeah, and we will
Sure, sure,
start.
sure, 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 sure.
Sure. Okay.
Thank you. Thank you.
So moving forward to the step how we can log in into the RU. As all colleges have a CUDU console currently, right now my PC is connected with that 5G CP through the Wi-Fi, and now I'm going to access the CUDU. Every college's CUDU having the different username, so every college can use their own username. So currently I was in DTU. So in DTU we can do the login using SSH. Here username is Candor. IP address is 172.16.0.4 and password is YZEC321. So as you see, we are logging into the Candor means CUDU of this DTU premises. Now we are going to access. Now we are going to access the RU from CU and DU. So we can do further SSH. We are using root user, root and the IP address of the radio 192.168.4.50, and password is VVDN. So as you see, now we are get login into the LPRU, same as demonstrated in this devices. So next thing, as during the installation and the UAT process, we have tell, well, your device is get properly synced means your network LEDs demonstrating as a stable green, then you have to push active.sh only. So, so if you want to check like your RU is in which state, you can check further via this command also. So we are moving to the log where all PTP synchronization log get created. For this, we need to go to the directory cd where log. If we go inside, if we do the ls, we'll see there is a sync PTP log will be created. If you read this log, you get to know your RU is in which state. For this, you need to run the tail command, tail -f, then the file name. So as of now, if you see, it is showing that RU is our in synchronized mode. So from this command also, you can check whether your RU is properly synchronized or not. And if you want to check like what is the bit width is configured inside the radio, you can use this command, sysrepo space -added is equal to cat -d startup pipeline grep IQ bit width. Actually, our radio support 9-bit, 12-bit, 16-bit, all kind of bit compression. So it depend upon the configuration when we are doing the integration. So depend upon the DU and CU configuration, you can change the bit width as well. So as you
Okay,
see
sir.
right now, our
Vishnu, sorry to interrupt you.
Mhm.
So, as already communicated by the Shoaib, so we will request all the institutions, please join that call because some expert from ITU sites, they will guide you regarding the upcoming the hackathon. So I think 5 to 10 minutes we will complete this training for the today. So we request once again to join that link.
okay, so Sonuji, we can cover in
Yeah,
five
yeah.
minutes.
Please cover. Make it fast.
Okay, sure, sure. So if you want to see like what is the bit width is configured inside the radio, so you can use this command. If you want to check the frequency, center frequency configuration inside the radio, you can use sysrefo edit cat startup grep absolute frequency center. So it will display
what is the absolute frequency center offset is configured inside this radio. So as of now you see like 64345 2 is configured. So this thing is required when you are going to do the integration with the cu and do. These kind of parameter is required. And for the bandwidth also you need to grab channel bandwidth. So as you see that our radio is configured for the 100 megahertz band. So that number system is showing in a hertz.
कॉन्फ़िगरेशन दिखाता है कॉन्फ़िगरेशन फ्रीक्वेंसी
दिखा दिए.
फ्रीक्वेंसी दिखा दिया
And if you want to see all the configuration, radio site, TX array, RX array, and what are the radio configuration is done inside this radio for this DU integration, simply you need to run this command. So it will display all the parameter which is configured inside this radio. It is a lengthy file, so all 4 channel TX, RX related all parameter will be visible into this. By using this command sysrepo config --edit cat -d running, so it will showcase all the radio parameter configured inside this. So initially it will showcase like what are the group user it is supported. It is supported user, FMPM, observer, installer, SWM. All these group are it is supported. And if you see TX and RX array side, this is the important. Your main RF parameter like bandwidth, center frequency, center channel bandwidth, what is configured you can see in this. And even you can see if you reboot the RU, right now if you see this parameter TX RX is active, so it will get inactive state. Even if your RU goes in out of sync, also at that time also it will go in a holdover state. After moving out from the holdover state, it will get into the inactive state, so your RU will not radiating more. So that's why every time when we reboot the RU, we will push that active.sh script inside the RU to make all the carrier active. So if you want to see the transceiver statistics, so you need to go in a path cd etc script path. So there you will get this RU. stat ru.sh. If you run that script, so it will showcase the uplink, downlink statistics on all four channels, like how what packets are going. So, and in RU side, we are supporting that CLI based configuration as well. If you further, if you want to do integration with a RAID CUDO, so there is a one CLI mode is also given in this radio to configure multiple kind of parameter inside the radio. So going into the CLI mode, you need to just type telnet localhost space 888 times. Then it will ask for that login credential username. So username is a ORAN user, and same password is also the same ORAN user. So when you get into this, so these couple of set of commands is available. With the help of this, is easily you can configure these parameter as well, like IPv4 static, IPv6, DSCP mode, software information, system MAC address, system app uptime. You will get will indicate, it will showcase what is configured. Set is used for if you want to set any parameter. So bandwidth, DL compression, PXSCH, PCID, all these configuration you can, even the VLAN tagging also you can do it from this CLI mode as well.
So we request you. We are training here to for the parameters, but don't try to change
Yes,
before
correct.
changing
Please,
any CUDU. Otherwise, your setup will be down. That will not work.
if
Because the
any of the,
parameters should be the same for both sides, RU sites and DU sites, DU config file sites.
because these information is required when you are further going to do the integration with new setup, or if you are changing something in a DU site, same configuration you need to configure on the radio side. If both devices are getting sync and having the same parameter configured, then both device will communicate with each other properly, and then your system will get work properly. Otherwise it will not came up. This is I'm demonstrating like for your future uses.
Yeah. Yeah, I think. Haji, Haji.
So now the most of the things in RU side, like is configuration and LED indication and CLI mode, and how to run this active.sh file, these, and even how we can log in into the RU also we had demonstrated. So if anyone having any doubt or question, they can ask.
Yeah, Vishnu, thank you very much. Yeah, actually, IPU team is waiting for this hackathon planning.
Okay, okay, okay.
Thank you once again, team, for your
Yeah,
support.
thank you all.
And
Thank you,
tomorrow we
Sonuji.
will start 11 a.m., 10:30 to 11 in between. So we request you once again, all the institution, please join that link. Every time DOT team is asking for the same. Thank you for your support.